Okay. Hopefully this is working. Um, okay. Nice. I'm setting up LeetCode and YouTube. Let's see. Is my audio good? Okay. Looks like it's pretty good. Let's see. Hmm. Okay. Okay. So today's goal for the stream is to solve LeetCode problems, mainly digit DP. My goal is to solve this question: total waviness. Total waviness of numbers in range 2. This is a hard problem, 2296 rated. Uses digit DP recently asked in bi-weekly contest 170. I was not able to solve this problem mainly because I didn't know digit DP. I was supposed to stream yesterday. Ah, yeah. I was supposed to stream yesterday, but it didn't work out. Uh, so hmm, okay. So yesterday I have solved a couple of problems. Let's see. Uh, this guy's pretty good. Why not, baby? Watched his videos and solved a couple of problems. हाँ ठीक है. Okay. Wow, I was not sharing my screen. Ah, shit. Okay. So, I've not seen this problem yet. This is me reading it for the first time. Problem number 902, numbers at most n given digit set. Okay. Given an array of digits which is sorted in non-decreasing order, which is basically increasing order, you can write numbers using each digits this as many times as you want. For example, if digit 1, comma 3, comma 5, we may write numbers such as 13551 and this. Okay. Hmm. Return the number of positive integers that can be generated that are less than or equal to a given integer n. Okay. Hmm. Okay, so we have a string, or basically characters, of different numbers, right? And our goal is to find all the possibilities or all the numbers that are less than 100. So there are a total of 20 such combinations or numbers which we can form using this digits array, which are less than 100. Hopefully I'm not muted. Okay, cool. Hmm. So what are the different states we need in solving this problem? Let's see. Uh, Different states required. First is definitely the index. Second is if it's tight or not. Third, we need to take care of the leading zeros. Why? Because the numbers can be less than uh, the given length of this number, which is 3 for 100, right? So if you want to see, suppose the number 10, we cannot create here, but suppose if we wanted to create the number 10, then we need to know whether or not it is the leading zero or not. Because if it is a leading zero, then we can take 0. But for example, if we see a number like 010, this is not a leading zero. This is not a leading zero. And it is also not present in our given digits. Hmm. Digits. Fine. Okay, this is good to know. Digits of I is a digit from 1 to 9. Okay. Hmm. I'm trying to think if for the tight, for tight, if if we want to set the upper bound, how what should be the condition? Mhm. Check if type equal to true, then we can say that the upper bound can be s dot char. We can convert this n into string s dot char at idx. If it's not a type, if the type is set to false, we can say that we need the upper bound. So we need the maximum number present in the digits array. Oh, my battery is low. I need to plug in. We need the max value present in digits. So we have to pre-compute the max value or the upper bound hmm, from the digits array. Okay. Hmm. So should I create an array list and store the values of the digits as integer values? Then when we iterate over the for loop over then we iterate over the array list array list because then we know the numbers we can select, right? We iterate over the array list and try different combinations. Okay, this makes sense. Let's see. First, create an array list of integers. Here are new array lists. Okay, for entire. What are the limits? 10 to the power 9. Makes sense. Digits is sorted in non-decreasing order. Oh yeah, which is in increasing order. Great. This is a good advantage. We don't need to sort. Anyways, the numbers can be from 0 to 9. which is a total length of 10. And if we try to sort it, the time complexity is going to be kind of off one. It is n log n, which is for a length of 10, it's O of 1. I right. So that should not be a problem. But it's good to have it in increasing order. Anyways, do I want to create a different uh structure for this, or should I just iterate over digits? But the problem is that for every call, I need to convert the string into an integer value, and that operation will take a lot of time. So, should I create or not? Should I create an array list or not? It's let's see. I think it's better to create an array list so that we don't have to repeatedly uh keep converting this value from string to integer. It's better to just convert it once. And anyways, the length is good. Oh, it's from 1 to 9. Interesting. We can have leading zeros though. Yes. Leading zeros is going to be a problem. But let's see. Let's figure it out. Int length equal to digits dot length less than that plus plus. Hmm. What do I want to do? Array dot add integer dot value of digits. Fun. Should I print it out? No, no, no. Print it. Now, hmm. Oh, this is an array. Okay, I just want to see whether or not it prints the number not. Okay, 1357. Okay, so it looks like it prints out the numbers. and that is plus just convert it once. Okay. Uh, we have the tight, and we do need to take care of the leading zeros. Do we need any other states? Is the question. Do we need other states? Leading zero is true. And also, we need to subtract zero from it, but the digits can never be zero. Hmm. No, there will be a case where this will create a problem, I guess. Let's see. If id x equal to s dot length, just return 1. We need to count the numbers. Int lower bound is 0, or is it 0? Lower bound will be always digit or not digit. Oh wait, we also need to send the array, of course. How did I forget that array? Array list, oh gosh, array dot get 0. Upper bound will be array dot get. I guess I need to set this as a global variable. This one. Uh, then -1. So the last digit. But we need to check a condition. Uh, if type is true, then get get the upper bound will be s dot caret idx. If it's not, then we are free to choose from the range of digits that we are given. Okay. Now uh iterate over the array, then that was plus. Oh, or rather upper bound, and this will be equal to. Okay. Lower bound. Now we check for invalid case and valid case. Let's see. What would be the invalid case? Hmm. Um, this is the direct value, but we need the index. This will be 0. This will be index of. Oh, no. We already have the index because we are taking over the array list. We need the indexes and not the actual characters there. This is not the actual digit. This is this is not the digit. This is the iterator in this case. Hmm. Because I need to consider leading zeros, right? I need to consider for leading zeros. Ldx plus 1 type and if digit or not digit. Array dot get I would equal to array dot get at upper bound. Hmm. Let's think about the leading zeros case. If leading zeros is true, should we just create a hash set that would be helpful, right? Just two of one lookups, and then we can iterate over all the characters. Just put it in a hash set. No need of an array list. Hash set. Hmm. So lower bound will be 0. Yes. And upper bound will be s dot char at idx. Otherwise, keep it 9. Keep it 9. We'll check all the combinations till 9, and the condition that the logic will be executed only if that number is in uh is in the hash set, right? So if this is digit, lower bound, upper bound, digit plus plus. So what will be the invalid case here? If we have leading zeros, because the thing is, if digit equal to 0 and leading zeros is true, what should we do now? Type is if type is true and digit equal to wait, but the digit hasn't started yet. So type will be type because we have not started creating the number yet, right? So the type will be what the initial value is, which is true in this case, which is the true value, but we'll send the parameter as type only because we don't want to create any problems. If digit equal to 0 and leading zeros is true, we call the solve function again. Leading zeros is true. So we'll pass leading zeros as is. Oh, and then set. Hmm. This will just increment the values, the index. Okay. So just or just if we have digit equal to 0 and we have a leading 0, do we continue but we don't increment the index, right? Do we need to increment the index? We need int result equal to 0, result plus equal to solve SIDX plus 1, type will be typed, and then if digit equal to upper bound, then the value for type will be set to true, and then if leading zeros is true and digit equal to 0, then set to true, else it's false, and then set. But this is the main condition where there was a I'm trying to think if we should continue here or call the solve function. for the next index. I think we call the solve function for the next index because it is a leading zero. This is a valid case, right? I mean, not a valid, but it is a case that we need to handle. This is not an invalid case, but uh, but we do need to check this condition. This is an important condition. Uh, if set if digit is not in the set, we just don't increment anything, we just don't add anything to the result. Only if it's in the set, we perform these operations, else we move on. I think this is required. We need to subtract this because the digits can be up to 1 and we need to subtract 1 from it, which is this the zero condition will cause a problem, will be offset by 1. But let's see. Let's try and run the code. Wow. Oh, yes. This is a hash set. Oops. Okay. Oh, return result. Knew it. Let's see if we face any other errors. Hopefully not. Let's go. Wrong answer. Oh, we are off by a lot. Hmm. So we just continue here. Wow, this condition had zero effect. I did try plus equal to here. What? Yes, there is only one way. Leading zeros and the 1. What is the second way of writing this? What? If we have 1, we can only write 1. This is. Hmm. Okay, I guess I have spent enough time on this problem. We'll check what
So hi everyone.
why not DP does. Let's see.
So today in this video we are going to solve this problem from LeetCode that goes by the name numbers at most and given digit set. And this is going to be the fifth video in this digit DB playlist, right? So before start, and if you want, I have uploaded till now, right? So if you want digits which is sorted in non-decreasing order, and you can write numbers using each digits of I as many times as we want. For example, if digits array is given something like 1, 3 and 5, then what we can do is we may write numbers such as 13 or 551 or like this. That is whatever the integers will be count of positive integers that
Wait, I need to check if leading zeros is set to false, else if digit is leading zero. Okay, okay. I think it should be like this. Uh, let's see. Oh,
that can be generated using this digits array, which will be less than or equal to the given integer n. So this is the question, and here we are given with three different examples, and this is the constraint. So one important thing to notice is that whatever integers will be present in the digits array, it will only comprise from 1 to 9. That is, only positive digits can be used. That is, you will never have to use the digit 0, right? So this is the question. I hope you understood this. So let us now try to first think why is it a digit DB question. So as we know that for a digit DB question, there are three requirements generally. First, the constraint will be little high. So here if you see, then the value of n can go up to 10 to the power 9, which is pretty high, right? So this is one indicator. Second thing is that you will be given a range. But if you look here in the problem, then by looking at it directly, you will not see a range, right? But if you see it closely, then you will realize that you are given an integer n, and since it is written that you have to generate the count of integers which will be less than or equal to this n, right? So it means that this n is our rightmost limit. And since we only have to return the count of positive integers, so it means that our leftmost value will be nothing but the 0. The range is indirectly given here from 0 to n. And the third indicator is that since in the output we just have to print one
that's this one. Yes, I get.
integer which will represent the count of only specific integers in that range. So the same thing is expected here too. So that's why this is a digit DB question. Got it? If you have not yet studied digit DB before and you are directly watching this video, then I will highly recommend you to watch and use it. Let us start now. So we know that the range that we have to deal with now is nothing but from 0 till n, right? So if this is the given range, then we know that what we have to do. So first we will solve it for the rightmost part, that is the solve of n, and then we will solve it for the leftmost part, 1 less than the given. So since 0 is written, so 0 minus 1. So this will be the thing here, and we know that
we are looking for 150 special people.
Okay, so it is from 0 to n. So we do not need the minus for 0 function because this will in itself calculate uh, the solve function will in itself calculate from the range 0 to n, which is this. Okay.
this will be equal to nothing but this solve of minus 1. That is, we have to check out for each and every possibility starting from 0 and going till minus 1 in this direction. And in this range, there is actually no integer. So that's why this will yield nothing but 0. So that's why the value of this part will be 0. So we can simply erase it. So that's why our whole focus will be on this part, that is solve of n. So this solve of n represents nothing but each and every integer present in this range, that is from 0 to n. So by solving, so that's why by calling this function, we will be actually exploring each and every integer present in this range, that is from 0 till n. And this is the same thing that we are given in this question as well, right? So that's why we are only concerned with the rightmost. And let me tell you one more thing. So since in this range 0 is also coming, but this 0 is actually not present in the digits array in any example. So since in this range 0 will also be one of the integer or the first integer, but since in the constraints it was written that the digits array can only comprise of digits from 1 to 9, that is whatever integer will form, it has to be positive, it can never be 0, right? So that's why what we can do now here is I will simply subtract 1 because we know that the 0 will never be a valid answer. So by calling and returning this, that is solve of n minus 1, what I will do now is I'm
Okay.
simply checking out each and every possible integer in this range, that is from 1 to n, right? And why I'm
Okay.
subtracting
Okay.
In this explicitly here, you will realize when I will write the code at the end. So this. So I hope you got this point. So let us move forward now. So let's say that I'm considering an example here. Let's say the value of n that I have considered here is something like, let's say 7, 4, 1, 6, 2, like this, right? So if I write the indexes here, then 0, 1, 2, 3, 4. And let's also suppose that the digits array that we are given here will comprise of some digits, and these digits will be like, so these digits will be like 3, 2, 8, and 9, right? So this is the value of n. These are the indexes, and here we are given the digits, right? So now we know what we have to do. We have to construct an integer which will comprise of a total of 5 blocks, right? So if I draw those 5 blocks here, so this will be our first block, second block, third, fourth, and fifth. So this is the first block, or the 0th index rather. First, second, third, fourth. So a total of 5 blocks are present, and we know that we have to start building an integer from this side, that is starting from MSB and going all the way till this LSB. So now we know that what we used to do in these types of problems. So what we do is, whatever value of n will be given, we will first convert it to a string. Why? Because we want to access these specific digits using their indexes, right? So in order to access the digits using the indexes, first we have to convert the given n into a string. And once this is done, let us start building our integer starting from this side and going.
Hopefully, I'm still streaming. And anyways, I'm still streaming.
For example, if digits array is given something like 1, 3, and 5, then what we can do is we may write numbers such as 13 or 5. That is, you will never have to use the digit 0, right? So this is the question. I hope you understood this. So let us now try to first
Yeah, I guess it's.
think why is it
What is this quality?
a
Okay,
digit question. So as we
okay.
know
The call. Okay, I was scared for a moment, but okay.
that for a digit question, there are 3 requirements generally. First, the constraint will be little high. So here, if you see, then the value of n can go up to 10 to the power 9.
Nice. Okay, cool.
All the way till this side, and we also know that whenever we cross this boundary, then the value of index that we will get is 5, and this 5 is nothing but the length of this integer. That is a total of 5
Yes.
different blocks, right? So let us
We'll
start with the first
return
block.
one
So
there.
initially we'll be standing on the 0th index, and we want to fill it, but with what values can we fill it? So since in the original string here for the 0th index the value written is 7, so it means that if I write here a value greater than 7, let's say 8 or 9,
This is set to true initially, yes.
what will happen is entire integer will become greater than this. But since in the question it was written that we always have to form an integer less than or equal to n, so it means that we can never fill 8 or 9 here. We can only fill starting from 0 till 7. So this is the only valid range that we can select. I hope you got this, right? So if I write here the possibilities of
Oh,
using the
wait. Oh, no. This 7. This makes
integers.
sense.
So we can select 0, 1, 2, 3, 4,
4,
5,
5, 6,
6, or
7.
7, right? And we know very well that we can divide this case into 2 different cases. That is, what we can do is, I can just say that this will be my first case and this will be a second case. Why? Because the second case represents nothing but the actual digit present in this string, that is at the 0th index, which is 7 here. So this is nothing but the upper bound. But we know that if you select any of the digits in the first case, that is from the first case, then if you select any digit from the first case, then from the next block onwards till the last block, the condition of type will turn to be false, right? Because if you select any integer from this range, that is from the first case, then no matter what digits you fill it here from 0 to 9, it will always be less than this n, which is a valid integer. So let's say I pick here this 7, that is the upper bound value only. So if I pick this 7 here, then what will happen? So let's say I pick here 7 now, and by picking 7,
What if?
I will move to the next. And since I have picked 7 here, which is actually present in this string, then when I have moved to this first index, that is the next, then I
The type will be set to true.
want to fill this block. And if you look in this string for the first index, which is written 4 here, so it means that I can only fill with this block from integers 0 to 4. And if I try to fill it with any integer greater than or equal to 5, then again the whole integer will become greater than this, which is wrong, right? This will be that it was then I picked here 7. But clearly in the digits array for this example, 7 is not present. And if 7 is not present, then whatever integer it will form at the end, in that integer 7 will definitely be present. And if 7 will be present, that is a digit is present, which is actually not present in this digits array. It means that the found integer will be an invalid one and it will not contribute plus 1 to our answer. It will not contribute, right? So that's why, let me erase these things. So that's why whenever we are filling it, we have to decide whether it is a valid digit or not. That is, whether that particular digit is actually present in the digits array or not, right? So if you look here, then starting from 0, we will see if this is actually present in the digits array or not. So as you can see here that the 0 is not present. And if the 0 is not present here, it means that we can simply not use the 0. Similarly for this one, because
Oh, wait. This will never execute this line. Because we never have 0. We'll never have a 0. Oh, I need to check this separately. This conditions if digit is 0. Wait. Oh, if digit is 0, this is the invalid case. I'm leading zeros and we have leading 0. then set the leading zero to be true. Because the set will never contain zero. So this line will never be executed if we write it inside this condition. Yes, this is true. This is true. This will be this should be ideally set to false because we have started a number. This will automatically handle the case where it becomes false. Also for this, it will handle the case automatically. Yes. Wow, the number just increased. I know this for a fact. I have to go -1. The type will be set to false, right? If we ever have a leading zero, instantly we can have any range. So type will be set to false. Hmm, let's see. The runtime is 7 milliseconds.
So this one is also not present, so we cannot use this one. But since this 2 is present here, then it means that we can use this 2. Similarly, since this 3 is also present here, so it means that we can use this 3, right? So if I mark here that what digits we can use actually, so it will be something like, we can use this 2, we can use this 3. And since we can only go till 7, and out of the remaining 4, 5, 6, 7, nothing is present here. It means that out of all the possibilities that we had initially, now we are only left with 2 possibilities. That is either we can select 2 or 3 for this first block. Why? I just explained you. Because these 2 and 3 are the
Hmm.
only digits that are present in this digits array, and no other digit is present. And if you select any other digit apart from these 2, then the whole integer will comprise of at least one digit which is not present in this digits array, and that form integer will be considered as invalid and it will not enter. Right, so that's why now we are remaining with 2 possibilities. Either we can select 2 or 3. So suppose after thinking, we decided to select it, let's say with 2. So if you select the 2, then what will happen? So here I selected 2, right? And I will then move to the next ender. And since here I selected 2, which is actually not the actual digit present in the string, then it means that if I select here and fill it with 2, then for the remaining part, the value of type will get false. That is, I can fill each and every block from 0 to 9, whatever we want, right?
Yes.
Because the value of type will get 0, because if I'm selecting here 2, which is not the upper bound, then we know that this thing happens. So, and even if you select 3, then the same thing will happen, because 3 is also not the upper bound value. So again, the value of type will be false for the remaining block, right? So suppose I selected 2 here and move to the next block. And when I have moved to the next block, then I know that we had the possibilities of selecting anything from 0 till 9, right? So the possibilities that are there for this first index is nothing but from 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And we know that this is just a one single case. We cannot divide it into two cases unlike before, right? Because there is no upper bound value present in this anymore. But again, you know very well that though we are allowed to select any value in this range now, but if we try to select any value apart from these 4, then again the whole integer will comprise of at least one digit which is not present again this time. So from 0, 3 to 8, right? So if that we can select is 3 to 8 and 9, and suppose out of these 4 possible digits, form till now is valid. And values that we are allowed to select is nothing but this 3 to 8, 9, and out of these 4 we can select any, right? So suppose we decided to select this, let's say 2. So if I selected 2, then what will happen? So if I select 2 here, so I selected 2. So let me write. So this is the integer. So in this I considered here, right? So that's why this is a valid integer and it will definitely contribute +1 to our answer. And in this way only we will try out each and every other possibility of 2, 3, 8, 9, and again 2, 3, 8, 9, and again 2, 3, 8, 9, and again 2, 3, 8, 9. So that's why by doing it like this, all the possibilities, that is all the possible integers, will be checked automatically. So I think this is the most important concept here till now. So let us now try to understand what states will be required in order to write this recursion. So as you might have guessed, that the first state that will be required here is nothing but the idx, because each time we are moving forward and the index is changing, right? So that's why this index will be our very first state. The second state here will be nothing but this type, because it is this will be an integer type, right? And let to n. So how the state is required here? So what will be your third state? So since in the question we want to try out each and every possibility in this range that is from 1 to n. So how this 1 will be checked and how this 2 will be checked? Because we want to test out each and every integer present between 1 to n. So in order to check 1, the form digit will look something like this. That is 0, 0, 0, 0, and then 1. Similarly, if you want to try out anything between 1 to n, that is from 1 till this n, let's say here something like 300, then again the form integer will look something like this, right? So in order to test 300, you can never ignore these leading zeros. This is what I'm trying to say here.
Yes.
So only if you write these 2 zeros here, then only these 300 will be written here. And in this way, the value of whole integer will represent
But oh, no, we cannot have
nothing but this
300.
300. And that's why you cannot ignore leading zeros here in this question. if you ignore leading zeros, then what it will do is it will never place 0 initially, right?
Yes.
And if it never places 0 initially, then it will miss out many of the integers less than
Hmm.
n, right? So that's why this leading zero will be our third state, which will help us to explore each and every integer less than n. And if you do not use this leading zero, then it will only start from this first block using either 2 or 3. That is
Hmm.
either 2 or 3, and that's why many such integers that can have been less than n and have been
Imagine.
Um, skip.
And if you have an option of selecting leading zeros as a state or not, then you should definitely select, because by using this leading zero as one of the state, what it does is it takes out each and every possible integer in that range successfully and does not ignore any integer. And since we want to check out each and every integer, that's why this leading zero is really important here, right? So now, once you have understood all of these things, the last thing that you should know is how we will actually check at each one of the index that if it is possible to use a particular digit or not. Because we know that when we were standing at the second index, then we had the possibility of selecting from 0 to 9. But out of all these 10 possibilities, the actual possibilities were these 4 only. So how we will know at a particular index if a particular current digit can be used or not? That is, we should have the idea of that this 3 can be used, this 2 can be used, this 8 can be used, and this 9 can be used. And only these 4 can be used. So how we will know this? So again, if you have watched my third video, then in that video, 8 can be used and this 9 will know at a particular index if a particular current digit can be used or not. That is, we should have the idea of that this 3 can be used, this 2 can be used, this 8 can be used, and this 9 can be used. And only these 4 can be used. So how we will know this?
Why 0 can also be used? It's not in the digits array. Digits is from 1 to 9. I guess
That is, we should have the idea of that this 3
here
can be used, this 2 can be used, this 8 can be used, and this 9 can be used. And only these 4 can be
here he's talking about the leading zeros and not the zeros which are after an actual digit in the digits array.
used. So how we will know this? So again, if you have watched my third video, then in that video I have explained the concept of bit masking. That is how we can use a mask in order to keep information. So in this question also we will do the same thing only.
Use a bit mask instead of a set.
That is, I will just use a mask here. So if I write it here, then it will be something like, I have defined a mask here, so this mask will be nothing but
Um, mm,
integer variable only, that is a total of 32 bits, that is starting from 0th bit and going till the 31st bit, right? And we know that since we only need to deal with the digits from 0 to 9, that is initially we know that all the digits will be turned off, that is unset, right? So each and every digit will be unset. Allowed to use is 3 to 8 and 9. So what we will do is for this third bit and the second bit and the 8th bit and the 9th bit, we will simply turn it on. So if we turn it on, then it will, we can use a particular digit or not, then we will simply see its value in this mask variable, right? So if in this mask variable for that current digit the bit is turned on, so if it is turned on, then it means that we can use it, right? There is no problem. But if it is turned off, then it means that we cannot use it. Why? Because actually that digit was not present in this digit array, and that's why it remained turned off in this mask also. So that's why this mask will be very helpful in this problem as well, right? So this is the whole logic I think required to solve this problem, and I told you each and everything in very detail how we will form the integer and what states will be required and why we cannot ignore leading zeros in this problem, because if we ignore the leading, also that's why this mask will remain constant if you do not want, and also how we will know that if we can use a particular digit at current position or not. So that's why we will use a mask here, and also that's why this mask will remain constant, right? So it will not change. So once we have updated the bits position initially using this digit array, this mask will remain constant. So that's why this mask is not one of my states in this problem. So now I think I've explained each and everything in very detail, and now it will be very good if you actually move to the coding part and code this up quickly, right? So let us go to the code editor now. As I told you that first we will declare a mask here. So the mask will use a value of 0 initially, and I will simply iterate through this digits array, and we know that each of the element of digits array is nothing but a string here, right? So that's why what I will do is I will first convert this given string into an integer, right? So a given string into an integer, that is this, and after converting it into an integer, I simply have to set its value in this mask array, mask integer, right? So by doing this thing, that is this, we will be actually setting each and every digit in this mask variable to 1, right? And once this is done, we know what we have to do. We have to convert the given and into a string, right? So that is this, and after converting it to the string, let's call the function here. Let's call it as, and we'll initially pass this string s, right? And let us start writing a function here now, index 0, and that if at any point the value of this index becomes equal to the string, right? So this. So now we know what we used to do. Check if this leading 0 was true till now and the current digit that we have selected is 0. So if this is the case, then it means that we want to explore other possibilities, that is integers less than n. So we will simply call out this function again, and this time the s will remain s, index will get increased by 1. So type value will depend like this, that is this. But we know that since we have selected 0 here, that is the given value will definitely be less than n. So that's why for the next block the condition of type will be false. So that's why you can simply write it 0 here, and the leading 0 condition will be true again. But
yes, that's what I have done. That's exactly what I have done. Leading zeros will be true. Yes, because it's true here. That's why, of course, it's going to be true here. Let's hard code it, but of course, it's going to be true there.
if it is not the case, then it means that the integer that you have selected right now is a non-zero integer. That is, the leading 0 condition will fail. But if it is a non-zero integer, then it might be present or it might not be present in this digits array. So in order to know whether if it is actually present in the digits array or not, we will use a mask here that I have declared. So let me pass the mask here as a last argument. So this is nothing but mask, and we will check if the current digit is actually not present in the mask. So I hope you know how to check this. I already have done this in the previous videos. So if this condition is true, it means that the current digit is actually not set in the mask. That is, it is turned in the mask. So I hope you know how to let me pass the mask here as a last argument. So this is nothing but mask. And we will check if the current digit is actually not present in the mask. So I hope you know how to check this. I already have done this in the previous videos. So if this condition is true, it means that the current digit is actually not set in the mask. That is, it is turned off. And if it is turned off, then it means that we cannot use it. So that's why I will simply continue this iteration. But if it is not the case, then it means that this current digit is actually present in the digits array because it is turned on in the mask. And that's why it means that we can use it definitely, right? So again, I will call the same function. The IDX value will increase by 1. And now the type value will depend like this, right? And we know that the leading 0 condition is broken now, so it will be 0, that is false. And this mask will remain as it is because it will not change. And finally, we will return this result. So let me declare this result variable here too. So this is because
This will obviously be set to 0 because it doesn't have 0 in it. 2. That condition will always be set to false because we don't have 0 in the set. That condition will always be set to false. But okay, we can hard code it here. Let's see. Why not set? Why can I not use a set? I actually want to print out the set, the values of set. Uh, set just have to go over a set. One three five seven 149 7 and hmm, files and when the test cases. No, that this is a silly mistake. This is a silly mistake. Wait. Okay, okay. Oh no. Ah, okay, let's see. So this is correct. Let's run it. This is correct. Oh, 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 oh. I didn't memorize it. Okay. I did not memorize this. Let's do that. Hmm. And DP, we have three states as of now. And new and the length. This is two as well. For int I equal to 0, I less than length I plus plus. For int j equal to 0, j is less than 2, j plus plus. dp of I j arrays dot fill. This will be set to -1. Okay, and we send a dp parameter. It's better to use a bit mask uh because we are not using any extra space, but I came up with a set solution, so we'll be using a set. I will be converting it into a mask solution. dp digit dp plus bit mask solution. Let's see. um okay, if the from dp of idx t and z and t equal to type. If this is true, set to 1. If false, set to 0. Same with z, which is leading zeros. If it's true, set to 1. If not, set to 0. Just store the value here. Oh, wait. If this is not equal to -1, then return the value of dp here. Else, just store the result before returning the value. That's it. This should work. And yeah, time limit exceeding. Makes sense. Oh, wait. Oh, Okay, I am back. Hopefully the stream's working. Okay. Okay, the audio is good as well. Uh, oh, didn't change my screen. So, okay. Hopefully this should work. I mean, it will work if I didn't make any silly mistakes. Uh, what? How is this out of bounds? IDX will be within the length. How is it going out of bounds? Oh, wait, wait. The length here is the array's length, not this whole. Um, oh, that's why. Oh, yes, that's why I wrote it below this. And nice. S dot length. S dot length. Just right. Oh, runtime 0. Let's say pretty efficient, pretty fast. Let's look at the what is this? Hmm. Let's look at the space complexity. Oh, not this. Oh, sorry. Yeah, it's using 42.40 MB of memory space. It's pretty fast. It's pretty efficient but uses space because of the hash set. Okay. Uh, I should convert it into GP plus bit mask. But first, let me copy this. Um, oh, how did I not copy this folder? Let's create a folder. Digit DP. This is home. Why is there a lag? Why is my camera? Oh no, wait a minute. Why is there a lag? My audio and camera is not in sync right now. This is not good. Hello, 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 hello. Okay. Okay, let's. Oh, wait. I need to switch my. Okay, let's. Camera. Wait. I need to switch my. Let's mute this and first copy this code, paste it here. We can add it thumbnail. Oh, using digit TP part one. This is the first one though. Git push. Okay. Let's convert this set into a mask. And how do we do that? Just initialize a mask equal to 0. Iterate over this digits array and then just turn on the mask 1. Left shift this by this many value of this many digits. Oh wait, I digits of I. Okay. We have a mask ready. Where is my function? I can send my mask. Instead of this, I can just say mask. Nice. Mask. If we have a leading zero, okay, just saying the because the stake won't change, right? For the mask, it will be constant. Just write your mask. If the current digit that we are on, this I'm doing this for safety, is turned on. Let's see. If the current digit, no, right shifted, if the current digit or is the mask right shifted, huh, the mask is right shifted this many amount of times, the digit amount of times, and we check and oh wait, not this and bitwise operator and one. If this is set to true, we move in. If it's not, we just we just don't execute because the digit is not in the mask. This makes sense. Is this what he had done? One and mask right shift digit. But if oh okay, this is correct. Hopefully this should work. Yes. Oh, the space complexity this time should be improved. Hopefully. It's still the same. Only 84 test cases. Wow. Okay. Surprising though. This was a good problem. Um, spent around an hour figuring out the solution. Oh, not ideal. I should be quicker. What did I just do? Okay. You can get my using digit dp. This is second or origin. Okay. 68%. Oh, is this? Hmm. Hmm. 233 problems solved, 21 hard problems solved. This was a good question. Very good question. How much time did I spend though? So, around 1 hour 30 minutes on a single problem, but it was a hard problem, but not that difficult. I could have solved it much quicker.
because it will not change. I think I realized it's that can be present in this digits array. So as you can see that the test cases are getting passed. So this solution, and we know that this 0 can never be one of the valid answer because the only digits that can be present in this digits array will be from 1 to 9. So this 0 will never be present, and if this 0 will never be present, then the 0th integer will never form. So that's why you have to subtract 1 here. And now if I run here, let's see. So as you can see that the test cases are getting passed. So this solution is correct, but let us try to memorize it further. So let us declare the states now. So since we have used a total of 3 states here, so this. So if you have already seen this here, if I describe you the same thing here, then the value of n can go up till 10 to the power 9. So it will be something like 1 and remaining 9 zeros, right? So this will be the case. And we know that this particular integer can never form because it is consisting of zeros. And 0 can never be present as one of the digits in the digits array. So if you try to take something 1 less than it, then it will be something in the indexing here, then this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So in order to access this ninth index, you must declare a size of 10 at least, right? So that's right till now. So much for watching this video till this point. I hope you really understood something new and it can be helpful in your upcoming interviews or online assessments or any competitive programming contests, right? So if you want me to make these kind of videos regularly, then please consider
What was this? I just saw a sliding window plus max question somewhere.
video of this digit DB playlist. So today in this video, we are going to solve this problem from LeetCode that goes by the name count of integers, right? So this problem will definitely use the concept of digit DB.
Count of integers. Is this the same problem? Oh, this is the same problem as this count special integers. Oh, and this is count of integers. Let's see. 2719, another hard level problem. 2719, count of integers. 2354. Rated problem. Huh. You're given two numeric strings, nums1 and nums2, and two integers, max sum and min sum. We denote, just a minute, few minutes ago. Well, Uh, we denote an integer x to be good if num1 is x is less than equal to num1 and greater than equal to num2. Okay, so we have a range. We have a range. Minimum sum, digit sum of x should be less than equal to minimum sum and greater than equal to should be greater than equal to minimum sum and less than equal to maximum sum. Return the number of good integers. Since the answer may be large, return it modulo 10 power 9 plus 7. Note that digit sum denotes the sum of the digits of x. Okay. 10 power 22. Nums1 and num2 can be up to 10 power 22. Wow. And minimum and maximum sum can be up to 400. Okay. We have a range. So obviously we have to subtract solve function for num2 minus solve function for num1 num1 minus 1, right? Solve function of num1 minus 1. Then we'll get the range between those two numbers. And the numbers are positive here, which is a plus point. Max sum equal to 8. What is the minimum sum? Oh, 1. Uh, oh, okay. This is basic UGDB problem, but once uh this is digit DP standard digit DP problem. Once we reach the base case, once we reach the base case, we we count the sum of the digits using another function. Uh, Using another function, and then check and then check if it lies within the uh, min sum and max sum range. Okay. If it is true, return 1, else 0. This makes sense, right? Hmm. But we already have the num1 and num2 in the string format, which is pretty efficient. Not efficient, which is pretty convenient. Oh, why did I check this? Wait, what? Mm, 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 then we know that. Calculate. We already know that. We, but my intuition is we find all the possibilities, all the numbers we find all the numbers which are less than and equal to the given number to num and then check the condition. uh, The condition. Hmm. Calculating the sum of all the digits will be in the worst case will be O of 22, right? Because the highest number it can go is 10 power 22, which is basically O of 1. And then calculating the different possibilities here, this will also be basically O of 1. Just wanted to check something. Into 8, 3, 4, 5, 6, 7. 6, 7. Okay, so this is below 10 power 8 operations. So it should suffice. This, this value plus this value plus uh plus or into 22. This is a problem. No, not into. We are not nesting it. We are not nesting it. So it's 9 factorial into 22 plus 22. This should pass. The time complexity is this basically in the worst case. It should pass. Let's see. I should start the timer. Start, start, stopwatch. Mhm. Increment sum maximum. Number one, public int solve string s idx a boolean type. Yeah, I should think for the different states that can be used. idx is 0, type will be true. What are the different states required in this problem. First, obviously the index. Second will be tight. Do we need a third one? We do, right? It is the leading zeros. Do we need to check for leading zeros? Do we need a different state or a condition for leading zeros? Hmm. Do we need a leading zero state? Ah, no, right? Do we care if we have a leading zero or if it's between? I don't think so. We need a leading zero here. Uh, int mod, just initialize it quickly. Yes, dot 123 123 127. If idx equal to s dot length, we check a couple of conditions here. I think we don't require any other state. 2 0 4. Minimum minimum and maximum. So should I send it in the parameters itself? Or should I? I'm just declaring it as a global variable. Min sum maximum. This dot. Oops. That's fine. Okay. Int sum equal to digit sum. Oh wow. Okay, so we need the entire digit here. We need to create okay int oops int number. This will be initially 0, obviously. Number. If min sum and sum is less than equal to max sum, then return 1, else return 0. We write the logic for public int digit sum int num uh int num. This is simple. Just I would just rather convert this into a string. Do I no, I don't need it. Uh just run it while num is not equal to 0, right? Uh int is int sum equal to this int digit equal to num modulo 10 sum plus equal to digit. Num divide by 10. That's it. Then just return the sum. Okay. Now just set the lower bound, which will be equal to 0, and upper bound, which we need to figure out. Oh, if this is if the current number is type, then we have to select the upper bound as the current digit present in the string, right? At that particular index. Else, we have the freedom to select any number from 0 to 9. Int result equal to 0 for int uh, digit equal to lower bound. Digit is less than equal to upper bound. Digit plus plus. What do we do here? Hmm. We don't care about the leading zeros, so that is not a problem. We just we are we just focus on constructing the number. We do care about the leading zeros. Us- we do. Because while creating the number, if we have a leading zero, the number will be set to 0. But once we stop having the leading zeros, we'll have an increment in the hmm, we'll have to increment the number. I don't think we need it. Let's see. Equal to solve s idx plus 1. We'll check if type is true and if digit is equal to the upper bound. Uh, Now what? Select upper bound and num number. Oops, into 10 plus the current digit. That's how you create the number. Yes. And oh what? And then return result. Okay. This should work. Let's see. Oh wait, of course. Still, why am I getting negative numbers? And how is it possible? Oh, hold on. What is this? How am I getting negative numbers? Oh wait. Oh, nums 2 minus nums 1. Because nums is always going to be greater. Yeah, nums is greater than. Oh, okay. This makes sense. But okay. I think I know. Okay. Here we are subtracting a number which is common in both twice. Oh no, this should be nums 1 minus 1. Uh Nums 1 minus 1. Just wanted to confirm something. If s dot char at id x equals to 7, what will be the output? It will be 7. So this -1. Yeah, yeah. Number. Integer dot value of num1 integer dot toString. Yes, this makes sense. This is correct. Now we have to just memorize the code, which is pretty easy. For wait, int pp. We only need two states. This is equal to wait. We need yeah, we can do it in a singular dp. But wait. Num2 dot length and this will be 2. Do we need this I think we should. No, this is not the sum. This is the number, right? The number it has created. So this will be equal to this to dot length. So we do need DP states. For int I equal to 0, I guess then um 1, 2 dot I plus for int j equal to 0, j is less than 2, j plus plus arrays dot fill dp of I j to -1. Int b nums b equal to this. B equal to this. B minus One number is not equal to -1. Just return this int p equal to, if this is tight, keep it 1, else make it 0. So I think this is the problem. Okay, the code is memorized as well. Let's see if it runs. Oh, we have to mod the result. Result is always. How did I forget that? Mod is for safety. Is mod to Why did this fail? One, wait. This should be wrong. This number will be wrong. Yes. Come on. Oh, uh, so because of thing. Hmm. This should not be watched. Yeah. So the key is we think now. How do you need some society? Hmm. This makes sense as well. Just why do I need this? And I can calculate the sum of the number. And sum. Hmm, that's really great because we are modeling it. This will be end. And I think we don't need this sum plus the digit. And then mod it. This will be sum. We check s- the value of sum only once we completed forming our numbers. We don't need this anymore. This. Uh, not this, then so looks good. Max it can go is 400. I'm just going to set it to 401. Next degree state is this. This should work. Uh, Nums block length 22. 22 into 2 into 401. This is of one time complexity. This should work. Oh, oh my God. Remove this.
and we will see how. So before starting the video, if you are new to this channel and have not yet created playlist with the sixth video, right, helpful in your minimum sum, right? We are given with these four integers initially, and we call an integer being x as a
Some statement. How is this wrong now? Oh, good. Your digit sum db array is too small. Maximum it can contain is 400. Is it, um, yeah, because 9 into s dot length, because there are 9 different possibilities that, that it can be in. Why, why 9? Why 10? Because we can't have zeros. Yeah, but if we add a zero, it doesn't contribute to anything. Oh yeah. Written you produce a negative. No, just hmm. This makes sense. And the other can be 9 into 9. हाँ हाँ ज़्यादा. 1 dot n. Sorry. From 2 dot n plus 1. And this will be 9 into num, because there can be 9 different states in a total span of num dot length, and then plus 1 because we need to contain up to that total number of states. Now, why would this be a problem? I need to figure this out. Yeah, yeah, the number can be negative, but how? If the max, if num2 is greater than num1, how am I getting a negative number? Hmm. Mhm.
Good integer. And the second condition is that the digits sum of that.
Hello, I think I need to go. We'll figure this out later, but I need to first uh, submit this. I kind of know why I'm doing this, but not sure. Why? Uh, I need to go. My mom is calling. Um, don't- what? What? Let me open LeetCode and let's check uh, if this is centered or not. What is happening? Um, okay, this needs to be full screen. Okay, this needs to be full screen.
we can use a particular digit or not, then we will simply
Oh, this was like this
using
since the
digit.
beginning. Okay, okay, so it's just the
use a
format.
particular digit or not, then we will simply
Okay, never mind. Um, cool. Mhm. Okay. So why did we get a runtime error? Probably because the number was too big. Here, num1. This it couldn't convert it. Okay, I had GPT'd the solution. Let's see. What is this? Okay. Mm, final return method is negative numbers. First of all, I need to understand why will this produce negative numbers? Because if we are subtracting a positive number from, oh sorry, a bigger number from a smaller number, the output should be positive. But then why is it coming negative? Wait, wait a minute. The numbers are positive, right? The numbers are from 1 to 10 power 22. Okay, no, but num2 is greater than num1. So the output should be positive, right? It always be negative because, but the problem is not the. Okay, how Java handles modulo. And the left operand is hmm, Okay. Okay. I understand. Yes. This is minus sign as well. I should have been careful. Okay, I get it. And yeah, in this code, uh, uh, this line through an error. What is the reason and how can I fix it? Here's why how to fix it. Okay. Reason num1 can be larger than long dot max value. Hmm. Num1 is numeric string from the input. Yes. In digit DP problem, like the inputs can be up to 10 power 9 digits long. Trying to do for input string because Java long type can store numbers up to using and hmm, uh, is there a better way of doing this? Let's see.
X should lie between this max sum and min sum, right? So what does this digit sum mean actually? So this means nothing but just the summation of all the digits present in the integer x. So if these two conditions are set and it is very high, you're directly watching this video, then I will highly recommend you with the basic concept. Always the third indicator. So that is from 1 to 8 inclusive, right? So that's why if you look here, then each and every integer present in this range from 1 to 12 except 9 will satisfy this criteria, because for the integer 9 the digit sum will be nothing but 9 only, which lies outside between 1 to 8. So that's why 9 will not be a part of it. But except 9, each and every integer present in this range from 1 to 12 will have a digit sum lying between these, that is from 1 to 8. So that's why the expected output for this example is 11, and the same thing will be done for this example as well. So since the num1 here is 1 and num2 is 5, so it means that our range is nothing but 1 to 5. That is a total of 5 integers. And since the minimum sum here is 1 and maximum sum is 5, so that's why for each of the integers present here, that is from 1 to 5, the digit sum will always lie between this range, that is from 1 to 5. So that's why the output here is nothing but 5. And that's why we are returning 5. So I hope that you have understood this problem till now. And let us now try to go strings. Calculate the total number of integers present in this range. That will be good integers present in this range. Then subtracting, most point is 7, and the same thing will, they are already given in the form of a string, right? And fourth, right? And that's why the total size of this integer is nothing but 5, right? So this is 1, right? So we already integer, it has to satisfy that and the digit sum and 9 with, I can fill it with 0. The conditioner decided to pick 7 here. So if I pick 7 here,
Can't trust.
now I'm standing on the first index, that is this. And here the digit present on this string is 8. And since the condition of type is true, so it again means that and this, that is the index value will come. Or should we contribute plus 1 to our answer? So we have to check whether the found integer, the digit sum of that integer actually lies in the expected range or not. Because it has to lie in this range. And if it is true, found integer is by the digit sum. So it should, that's why this is a valid found integer and it should contribute plus 1 to our answer. So this is the whole logic here. And we will do the same for each and every integer present in this range. That is from 0 till this n. We don't have to worry about this because by giving each of the choices in each recursive call, it will actually explore each and every possibility. That is each and every integer present in this range. And whatever good integers will be there, it will count them as good and contribute plus 1 to the answer. So let us now try to discuss what states will be used here. So clearly, since we are moving each time forward by one step, so that's why I can say that my first state will be nothing but this index value, right? It means no digit has been chosen 8 plus 2. So let's call it sum only. So for the leftmost part. But since in the input you are given this num1 and num2, if I show you, then in the num1 and num2 in the form of a string, which is actually given in the form of a string, which is a good thing for us, right? So we don't. So that's why we are not worried about this num2. But this num1. So see, we are actually using num1 minus 1 here and not num1 actually.
Yes.
Right? And if I show you, then in the constraint you can see that the value of num1 and num2 can go up to 10 to the power 22, right? So that's why when you will try to convert this string into an integer or a long value and reduce it by 1 and again
And uh, what number can int and a long uh up to what number can int and long up to what number can int long data types fit? Okay. Mm. Okay.
convert it into a string in order to use that num1 minus 1 value, then it will create problems. So you cannot convert it directly. That is, you cannot convert this given num1 into a number and again into a string. So that's what we will do instead is that we will not convert this num1 string into an integer in order to reduce it by 1. We will simply play with the string only that we are given in order to reduce this by 1. Right? So that's why whatever num1 string will be given, we will not convert it into a number in order to reduce it by 1. Whatever string will be given, we will simply play with that string only, starting from the backward side, that is the last index, and going all the way till the 0th index in order to decrease it by 1. So it will be nothing but a simple logic only that we will be doing in order to convert this num1 to num1 minus 1 string. I think it will be very good for us if we move to the coding part and write this recursive solution and after writing this recursive solution, we will further see how we can map to number index and going number in order to reduce it by 1. Whatever string will be given, we will simply play with that string only, starting from the backward side, that is the last index, and going all the way till the 0th index in order to decrease it by 1. So it will be nothing but a simple logic only that we will be doing in order to convert this number to number minus 1 string. I think it will be very good for us if we move to the coding part and write this recursive, this number and num2. So what I will do instead is I will call a function, let's call it subtract 1, right? And I will simply pass this num1. And whatever it will return, it will be actually this num1 only that has been reduced by 1. So first we'll be doing this, and in order to do this, let us start writing this function here. So,
So basically he
let's call this function
created
as
a
subtract
function
1,
only
as written below, and a string will be passed like
of
this.
subtract
So,
1.
and will be the size for the string, right? And the index that we will start initially will be the last index, that is n minus 1. And until and unless the current index is not 0, so I will simply check if the current character is greater than 0 or not. So if it is greater than 0, then it simply means that I have to decrease it by 1, right? And I will break, right? But if it is not the case, then it means that the current character is 0. And if the current character is 0, then I will simply set it to 9. And then do a I minus minus. And after this is done, we will simply check the 0th index is actually the 0th character or not. So if it is 0th character and the string size that has been found is greater than 1, so it means that from whatever index, the first digit will be 1, we have to extract from that index, right? So that's why I will return this, right? But if it is not the case, then it means that I simply have to return
Size dot substring 1.
whatever string has been formed till now. That is s only. So by writing this function and calling this function, convert the given num1 to num1 minus 1, which will be our nothing but the leftmost limit, and the rightmost limit is already this. It will simply that I simply have to return whatever string has been formed till now. That is s only. So
Now, what does s dot substring r in what remove the leading zero? Uh, let's see, so we have to write a function to subtract this 1. Subtract 1. We'll pass num1 into it. Ouch. Public int subtract 1 will pass get a string s. Oh, this is a string as well. Return num. Let's call it num. Or rather s. Uh, I think I will create a string builder. String builder sb new string builder convert uh, this string to char array. Okay, now just iterate over this. Oh no, while int n equal to s dot size, or just do array dot length. I believe that's slightly better, faster. Both are often operations, but even though uh while I is greater than equal to 0, and and array of I equal to 0, I int I equal to n minus 1. If array of I if in this is set this value to 9, I minus minus. Now if I is greater than equal to 0, and why does this and look a bit different? I don't know. If I is greater than 0, greater than equal to 0, and array of I is not equal to 0, then we set array of I equal to array of I minus. Now, can I do this? I guess I can. Yes. Hmm. It will not be equal. Of course, it will not be equal to 0 because this will break. But no, but what if the I exhausts here, it reaches 0 and still array of I, no, but if it reaches 0 here, this will become, I will become -1. So this condition will not be satisfied. Okay, so the 0th character should have, okay, what I'm trying to say is, if we have a number, say 000, we are on this character, it is 0. We move back, oh my god. We are on this character, it is 0. We subtract again, we are on this character, we subtract again. We are on this character, we subtract again. This character subtract again. Now here I becomes -1. So this condition will never satisfy, right? And if we have a 1 here, uh, the ith position is here. We go into the loop, decrement the value of I becomes equal to 0. Yes, I becomes equal to 0. Uh, and it is greater than equal to 0. I is greater than equal to 0, which means that we can decrement the value. Yes, this makes sense. Okay, this is this. Now, I saw something about leading zeros. Remove leading zeros la except for last digit and start. Uh, if start is less than a dot length minus 1 and a of start equal to 0. Okay, I need an example to understand this. Yeah, what if the entire thing is equal to 0? Hmm. Okay, this makes sense. If this is the number, I becomes equal to 0. This is 999. Okay, I becomes equal to 0, then you need to remove the leading zeros. Okay, remove the leading zero and start. No, okay, and start equal to 0 while start is le less than less than n, and this array of start is equal to 0, then we increment is less than n minus 1. We increment the start because we don't want to remove the last character. Right. Oh, that was smooth. Okay. This then either we can return new string array from where to start, where to end. I believe that's how you write it. A dot length minus start. Okay, I need to understand the syntax. Explain this syntax. I have never seen the syntax before. This is the first time. Okay, I believe this is a start length and the end length. Int offset, int count. Okay, so this is a number of characters to copy. Okay, this makes sense. A dot length minus start. Array. Wow. So basically it doesn't subtract the number properly. So it cannot be asked. This line is wrong. Wow. Returns the old value. Oh my god. Okay, great. It works now. This was basically, where is it? This was basically the basics of increment and decrement operators, which is if, uh, let's say let's say if you have a variable a and you decrement it as a minus minus, then what it does is first stores the value of a here and then decrements the value of a. So technically you're storing the same value. This is known as post decrement. This is pre-decrement, where you decrement the value first, then store the value in the variable. This is just the basics. Or you can directly use a decrement operator, which is array of I, or basically a minus minus. Uh, yeah, which will directly decrement the value. Yeah. Okay. Let's go. This should pass. Nice. Hmm, I just copied this. The push. Oh, reset. These are pretty difficult questions, not gonna lie. Why did my batch not change? I have received the 100 days batch. Okay, not this. Hmm, let's see. Uh, okay. So I have basically solved all the questions in this playlist. Oh my.
digit sum actually lies in the given range, that is 1. Otherwise, we will return this sum here. But if it is not the case, then it means that it is allowed. Sorry, instead of passing these arguments here, I should have passed it there only. So, like this. And the maximum value is 10 to the power 22, which is clearly not the. If we try to take the digit sum of this, then it will be equal to nothing but this 9 into 22, right? Which is nothing but 198. And in order to access this 198, you must declare a size of 199. So that's why the size here will be nothing but 199. And let us also do, in order to access this 198, you must declare the size of 199. So that's why the
Yes.
size here will be nothing but
This
199.
was pretty
And let
important.
us also do a min set here for each of the functions, or not.
Okay. Let's see. Oh, we have CSCS problems as well. Wow. DP on freeze. Hmm. Let's
So hi
do
everyone, so today in this
this.
video we
Okay.
will be discussing an interesting code forces problem from code forces round 925 div 3, and it is rated 1700. The problem goes by the name chat screenshots. So what does this problem say is, there are
Okay, I will solve this later. First of all, I need to solve this question. Where is it? Not this. Yeah, this. Found special integers. Let's see if I'm able to solve this or not. Found special integers. Okay. We call a positive integer special if all of its digits are distinct. Okay. This is a straightforward question, pretty easy. Given a positive integer n, return the number of special integers that belong to the interval 1 comma n. Um, Constraints are high, obviously. What was I going to check? Given a positive integer, can the number of special integers that belong to the interval 1 comma 9, 1 comma n. Okay. Huh. Okay. I was going to write a few comments.
This was like this since the
Using
beginning. Okay. Okay. And
minus minus. Uh, let's go. This should pass. Nice. But these are pretty difficult questions, not gonna lie. These are pretty difficult questions, not gonna lie. Why did my batch not change? I have received the 100 days batch. Okay, so it's broken. Hmm. Three views. Oh, this was just me. Not one. Yeah, 2 hours 48 minutes. Let's see the exact time. What? 5 hours 7 minutes. Average viewed. Oh, this is 2 minute 48 seconds. Okay. Hmm. Nice. Okay. Let's see. We call if all its digits are distinct. Uh, this feels like an easy problem now because I know digit DB. But let's see. Let's solve. Let's solve couple of problems. Hmm. What are the states required? First is obviously index. Second is type. Third, uh, well, we need a mask, and also, let's keep this as the third one. We need leading zeros, and fourth is the mask, which will contain all the distinct numbers. Oops. Hmm. That's it. Mm, okay. If we have from 1 to n, right? So if we have the number 0, given a positive integer, this special integer that belong to interval this. 0 can be considered a special integer because it is a single number. which is distinct, but we don't want to include that. So we can directly do a -1. String is equal to integer dot to string n. Okay. Return solve as let's copy this. Oh, bada boom. Okay. Public int solve. String s. We need our index. We need a boolean type. We do need leading zeros, boolean, and we need our mask. Hmm. Index is 0, type is set to true, leading 0 is set to true, and mask initially it is 0. Okay. So if index equal to s dot length, we have found a, a positive integer that has distinct digits in it, right? So we return plus return 1. Yeah, we return 1. Let's set the lower bound, the upper bound, which is if type is set to true, then s dot char idx this or 9. Let's initialize our result. Now for int I equal for int digit equal to lower bound digit is less than equal to upper bound and digit plus plus. Let's see. We will have an invalid case and a valid case. Basically, invalid case, valid case if what is in if uh if we already have that digit, if we already have the digit in the mask, just continue to the next number. If how do I write this? If mask charging, if this number is set to 1, which is we already have this number while creating the number, just continue because we don't need any duplicates. But if we don't have that, we move on to our valid case. बस झोपत्यात आहे ते Hello, hello. Okay. Hello, 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 hello. Okay. Hello, 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 hello. Okay. Cool. Okay. So this is invalid case. Now we come to the valid case. We add. Do we have to mod? No. Okay. Hmm. Result of solve. We send S index plus one. Check if tight and if the current digit and the upper bound digit is same or not. If it is true, it will return true. If false, it will return false. Leading zeros. Now this, okay. If leading zeros mm, um, we also need to check that if leading zeros is not true and if this is true, which is equal to, it becomes equal to 1, then continue. Hmm. Okay. If leading 0 is true and the current digit is equal to 0, then return true. If not, then return false. Now, this is an interesting case. If we if the leading 0 is true, if the leading 0 is true, then we return the mask as is, else we have to perform an operation, which is setting the digit bit digit bit to 1. So how can we set a bit to 1? By a mask or one left shift digit amount of times. We'll just take this here. Okay, the brackets are correct as well. This should work, right? If leading 0 is true, just return the mask. If it is false, then we can convert. Hmm, hmm. No, but we need to check new as a Boolean new leading 0 equal to this condition. We pass new leading 0 because we need to check if it's currently true or not. Yes, new leading 0 and int new mask equal to if new leading 0 is set to false, that's when uh wait, we need to initialize mask with some value, right? This is equal to 0 for now. If the leading 0 or new leading 0 is true, but if it is false, we'll assign it a value which is this. We'll set this to mask. Perfect. And new mask. Return result. It should be good. We can memorize it. But first, let's see if it passes all the test case or not. Okay, I forgot the semicolon. Anything else? I don't think so. And the receiver. Oh yeah. Oh, and a -1. As I discussed earlier, we'll obviously do a -1. Uh, because we have we need to find distinct digits till up to the integer n from 1 to n, so 0 will not be considered, right? And while solving this, while calling this function, we calculate the distinct digits from n to 0, and 0 in itself is a distinct integer, right? So we need to subtract that one from it. Oh, God. I need to check how this looks. I need hello, hello, hello. Okay. Of solve. If it is true, it will return true. If we return the mask as is, else we have to perform an operation, which is setting the digit bit digit bit to 1. So how can we set a bit to 1? Should be good. Set semicolon. I don't think so. Oh, and a -1. As I discussed earlier, we'll obviously do a -1 uh, because uh, we have we need to find distinct digits till up to integer n from 1 to n, so 0 will not be considered, right? And while solving this, while calling this function, we calculate the distinct digits from n to 0, and 0 in itself is a distinct integer, right? So we need to subtract that one. Okay, the audio is fine, everything's fine. Okay. This should work. I just need to memorize the code and we should be good. Yes, memorizing the code is pretty easy. And DP, we need 4 states. 1, 2, 3, 4 equal to new int. 1, 2, 3, 4 Okay. So the first one is obviously the length int len equal to s dot length. Then what do we need? Second, we have a type which is of size 2. Basically, Boolean value which is true or false. So 0 or 1. Then we again have a Boolean value leading zeros of size 2, true or false, which is basically 0 or 1. Then we have a mask. This is an interesting case, right? Because we can have 9 states and the maximum length of the string can be uh maximum length of the string can be 9, right? 10 power 9. Yes. So the maximum length can be 9. So 9 states and 9 length plus 1. So it should be 9 into length plus 1. Yeah. dp in dp 1 2 3 4 1 2 3 4. Oops. Okay, this makes sense. dp okay. Uh, if dp of id x t z and mask yes is not equal to -1, then return this. Boom. Else, before returning result, just store it into that dp. Now we do need to calculate what is t. If t equals to if it if the value for type is true, then wait, is this how? Okay. Oh, we assign the value 1 or we assign the value 0. Int z equal to, if we have leading zeros, then assign the value 1, else 0. Okay, this makes sense. This should work. First, let's assign the initial value for the RDP states. Then I plus plus for int. This is for t equal to 0. T is less than 2. T plus plus. Then for int z equal to 0, z is less than 2, z plus plus, and then just arrays dot fill dp of I, t, and z to -1. That's it. We should be good. Wow. Why? We have a oh wait. We have a mask. It should be 2 because the mask can only contain 0 and 1. So we have 2 states and it should be 2 power the length, because we have two states and n places to fill, which is 2 power the length and then plus 1. Math dot power 2 comma length and plus 1. Ah, this is not good. Int. Okay, this should work now. Hi.
Initial. So hello everyone.
This SQL
आज एआई ट्रेनिंग
So hello everyone. Skip it. Okay. One left shift to choose any for retaken. We won't take it again. We created a new one. It becomes 0. That means that always it will. We obviously this step is same, but this changes that we always have a not right case. As we sum of the answer, we memorize the solution using pause, type, and mask. This is a DP series. I will solution using pause, type, and mask.
Wow. So he, hmm.
And this is our solution. In this case, as we were, it's not very difficult. Memorize the same, but this include when we hit s dot size our particular other string of that, and then what we do a size plus 1. And then we create a 3D DP to memorize it. That's all right. Okay.
1024, which is 2 power 10. Hmm. This is the length for the mask. Basically, the different states can be in. So, why is this not correct? What are the errors in this code? Hmm. Alright, this is true. I should check the more than 0 here. Mhm. If current is equal to 1,
Okay. Mhm. Mask. The criteria is the mask size must be this and the duplicate digit. Check this. Putting in essentially that. But is this wrong though? Is this wrong? It should not be wrong. Digits. Hmm. Okay. It should be 1024. Why? Uh, because we have this is not it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay. We have 2 into 10 to the power 9 numbers, which means that we can have at least 9 digits, valid digits, right? And each digit, each digit can have a 0 or 1, right? Hmm. So the combination of having these zeros and 1 is 2 to the power 9, or to be safe, we can do 2 to the power 10, which is what is it? Just a minute. Which is 1024, right? Hmm. So this makes sense. Yes. Let's see. Hmm. This works. Okay. But first, I got accepted. But first, let's solve sum. Get and it comment. But let's first solve the daily problem now. I guess it's time.
push. Or should I do it? I should. I should do it. Digit DP. I forgot to name or add the extension digit DP here. Get status. Get remove 2376. Yes. Get add this. Get wait. I have already done all of this. Get push. This gets pushed. Perfect. Okay. Let's solve today's daily problem. I have not yet seen the problem yet. Let's see. Found collision on a road. There are n cars on an infinitely long road. Okay. The cars are numbered from 0 to n minus 1, from left to right, and each car is present at a unique point. The car from left to right, and each car is present at a unique point. You are given zero index string directions of length n. Directions can be either L, R, or S. Okay, which should be left, right, or straight. Okay. Hmm. Denoting whether the ith car is moving left towards right or staying at its current point, respectively. Each moving car has the same speed. The number of collisions can be calculated as follows. When two cars are moving in opposite directions, collide with each other, the number of collisions is increases by 2. Okay. When a moving car collides with a stationary car, okay, as is staying. So okay. A stationary car, the number of collision increases by 1. After a collision, the cars involved can no longer move. After collision, the cars involved can no longer move and will stay at the point where they collided. Hmm. Other than that, cars cannot change their state or direction of motion. Okay. Return the total number of collisions. What will happen on the road? Okay. Right. This is left. So we have a collision here. Hmm. If we have a collision, the cars stop moving. So we'll not consider this index and move on to the next index. right? Car 0 and 1 will collide with each other since they are moving in opposite. The number of collision becomes 2. Cars, okay, car 2 and 3. Okay. Hmm. This will give us 1, then we have left and again left. So it will keep moving left. So the answer is 2 plus 3. Cars 3 and 4 will collide with each other. 0, 1, 2, 3. 3 and 4. Okay. Car no longer move and will stay at the point where they collided. Other than that, the cars cannot change their state or during. Okay. So this K value updates whenever there is a crash to the latest ith position where the crash occurred. Okay. With the car 4 collides with car 3, it will stay. 0, 1, 2, 3. Left, right, right. This is left, this is right. There will be no collisions. Constraints at 10 power 5. So it is a O of n solution. Okay. Hmm. Oops. Okay, let's see. Um, what do we have? If the current position has the character R and then I plus 1 character has the character L or S for that matter, we okay, if it's L, we increase the count by 2. Uh if it's S, we increase the count by 1. And then for L, hmm, if we if we find a position I where the character is R and then I plus 1 where the character is L, we make we make I plus 1 character which is the L equal to S, which is stay, right? Because it will stop right there after the collision. Hmm. That makes sense. Will stay. So, for example, if we take this If we take this example, we have R. Then we check for I plus 1 character, which is L. So we increase the count by 2. Now, since we encountered an L, we make it equal to S. Okay, then we move on. We move on to the S character, where S is stay and R and S is stay and the next character is R. So we don't do anything. Okay, R. Now we have a R and then the next character is S. So we increase the count by 1. Now we are at S and the next character is L. If we find L here, what do? We found a crash, a collision which will result in an increase of 2. Okay. Now, if okay, then- wait, no, this will increase to 1. So converting this to left hand, converting this to S is not ideal. It should be L only. And this is L. Wait, this collides and then it stays. So it contributes to only 1. Okay, so it is beneficial to convert it to S. My bad. Now we encounter L. So we look behind. If we have L, we look behind and we have a S here. So it will contribute a +1. If we have left and a R behind, we do nothing. Okay, so there are a couple of points that we need to note down. If we encounter R, what do? Check if the next character is L or S. If it is L, collision plus equal to 2. If it is S, collision plus equal to 1. If it's S, we just move on. We don't check anything. Or do we? No, we don't. We don't need to. If it's L or S, okay. If we encounter L, check if the previous character previous character is S. Wait, if it is L, collision plus equal to 2, and make L equal to S. Character. Check if the previous character is S. If it is S, if it is S, then collision plus equal to 1. If it is R, ignore. Ignore. Why? Because we would have already calculated in this case. We don't want to double count it, right? And anyways, this case will never encounter this case. We will never encounter this case because we convert L to S when we see R. Oops. Okay. Why? Because we would have already calculated in this case. We don't want to double count it, right? And anyways, this case will never encounter this case. We okay. The stream's going good. Oh, wait. Did I disconnect? Hopefully not. I disconnect. Hopefully not. Okay. Huh. Okay, this is it. I think we should simulate it. Let's see. Let's run it. My charging is at 16%. Okay, let's see. Uh, we have a string where it is. Okay, first we'll convert directions to an array of characters. Let's do it. Let's do that first. AR, let's name it dir. New character, no, directions. I'm not typing this. Directions dot to char array. Now we iterate over the directions array. Okay, this will work. For int I equal to 0, I less than int n equal to dir dot length n I plus plus. Let's see. Char ch equal to dir of I. If ch equal to r, then we perform these operations. We check if I plus 1 is less than n, then if I plus 1 is less than n, then we check if we can just append it here and then this. If this is true, then we check if array, sorry, dir of I plus 1 equal to L. If it's L, wait, what if there are a sequence of R, 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 then L? So here R, L. So the collisions will be equal to 2. Oh, here count, count, count will be equal to 2, then plus 1. Why? Because we have this R here, and this will become equal to stay S, which is stay. So we need to keep in mind. So can we do this? In one iteration, we make every collision equal to S. For example, if we see R and L, we make R and L equal to S. Then in the second iteration, we'll find out if this R collides with S or not. If it does, then plus 1. Basically check if we encounter any character which is not equal to S. Do, if we do, then increase the count by plus 1. Okay. So in one iteration, if do we just check if R and L, if at ith position, if if at the ith position R if at that position we have R and I plus 1 position we have L. If this is true, if this is true, then then we set both position equal to S. Okay. So if this is true, just set dir of I equal to S. Oh, and same goes for dir I plus 1. If hmm, hmm, if at this point we encounter any R, if at this point we encounter any R and then S, we don't count anything because in the second iteration we'll consider this and increase the count uh by 1. Okay. Hmm. We don't need this. This makes sense. The battery is low. I should plug in. Okay. This. We loop over again for this. Okay, so we can directly give a condition here. Okay, now is less than n I plus plus. If uh, eh, sorry, if dir of I is not equal to s, then what do? We increase the count by 1. Here we increase the count by 2. Int count equal to 0. Return count. Oh, what if they are not in the same direction? No, okay. Okay, so we check. Okay, basically in the first iteration, we eliminate all the collisions where the collisions are in the opposite direction. Now what we have is uh, all the cars moving in the same direction. Okay, okay, wait. I need to plug in my charger first. Nice. Oh, my camera is important. Wow. Yeah, I deleted this instance and created a new one, right? Properties, transform horizontal. Yes. Okay. Hello. Now, here, hmm, how should we handle this? Here, we eliminate all the cases where the collision occurs in opposite directions. In opposite direction. Now here we have all the collisions that can occur. Hmm, that can occur. Okay, so we just need to find whether or not we have seen S or not yet. For L, if we encounter L, we need to check whether or not we have seen S before or not. Okay. We now here we collisions that can occur. Okay. So I'll create a boolean scene for S, which is set to false initially. If we have seen S, which is S, and wait, if wait, if character ch equal to dir of I, if ch equal to S set scene to equal to true. Now, if we have already seen the character and the current character is equal to L, then we increment the count by 1. Yes. We also need a variable right if, that is, if, yeah, after this we need to check if if right is greater than 0, then count plus equal to right. If ch equal to r right plus plus. And after doing this, initialize right to 0. We have these cases. Okay. This should be nested. Uh, yep. Okay. Why? Hmm, because if this is the first encounter of S, we need to calculate all the values of right and then add it to the count and mark scene equal to true. Now, why scene equal to true? Because in the future, if we ever encounter L, all the L is going to clash with the scene, with the S, which is the which we have encountered previously, right? And the hmm, yeah, correct. Then uh okay. Now for right, if we encounter an S, we need to know all the characters in the right. All the we need to know the number of R's encountered before this S so that we can count the value, uh, increment the value by the amount of R's we have seen earlier, and then set the amount of R's that we have seen at this point equal to 0, because we start fresh, right? Because now these because now these cars which are moving in the right direction have collided already. So in so we make a new start. That's why we initialize right equal to 0. Okay, this should work. Yes. Should I submit it? Let's see. Hmm. Nice. It got accepted. Um, let's-
If you're still typing your coding prompts, you're leaving performance.
Build
4 करोड़
हेलो एवरीवन, वेलकम टू माय चैनल कोड स्टोरी विद माइक। तो आज अपने लीड कोड का 1513 करने जा रहे हैं, मीडियम मार्क्ड है। ठीक है, इस प्रॉब्लम में एक चीज़ इंटरेस्टिंग पता है क्या है, मैंने इस प्रॉब्लम को फेस किया था एक ऑनलाइन असेसमेंट में। आई कैनॉट रिकॉल कि कौन सी कंपनी थी, क्योंकि मैंने बहुत पहले इंटरव्यू दिए थे और हैकर रैंक पोर्टल में ये क्वेश्चन आया था। बट इस क्वेश्चन में जहाँ कार मेंशन है उसकी जगह रोबोट्स था। दैट्स इट, बाकी पूरा का प्रॉब्लम ही सेम था। ओके, अभी बताता हूँ। तो उससे पहले मोटिवेशन, द मोस्ट इफेक्टिव वे टू ग्रो इज बाई वर्किंग ऑन योर मिस्टेक्स और फेलियर्स एंड लर्निंग फ्रॉम इट। ठीक है, अगर आप अपने मिस्टेक करने से डरते नहीं हो, फेल होने से डरते नहीं हो, और जो मिस्टेक करते हो उसे सीखते हो, तो आपसे जल्दी कोई ग्रो कर ही नहीं पाएगा, है ना। यू विल बी द फास्टेस्ट टू ग्रो। डोंट बी अफ्रेड ऑफ फेलियर। ओके, एंड इट्स एन अल्टीमेट टीचर। आपका मिस्टेक और आपका फेलियर ही आपका सबसे बड़ा टीचर होता है। ओके, तो मैंने जैसे कि मैंने बताया कि ऑनलाइन असेसमेंट में पूछा जा चुका है मुझसे ये प्रॉब्लम, कार की जगह बस रोबोट्स मेंशन था प्रॉब्लम में, बाकी सब कुछ सेम था। ओके, और बहुत आसान तरीके से इसको बनाया जा सकता है। देखो ध्यान देना, काउंट कॉलिजन्स ऑन अ रोड, देयर आर n कार्स ऑन एन इनफिनिट लॉन्ग रोड, द कार्स आर नंबर्ड फ्रॉम 0 to n-1 फ्रॉम लेफ्ट टू राइट, एंड ईच कार इज प्रेजेंट एट अ यूनिक पॉइंट। ठीक है, एक इनफिनिट लॉन्ग रोड है और बहुत सारे कार ऐसे रखे हुए लाइन से। ओके, अब क्या बोला, यू आर गिवन 0 इंडेक्स स्ट्रिंग डायरेक्शंस ऑफ लेंथ n, डायरेक्शंस i कैन बी इधर l और s, डिनोटिंग विद द ith कार इज मूविंग टुवर्ड्स लेफ्ट। l मतलब लेफ्ट हुआ, r मतलब राइट हुआ, और s मतलब स्टेइंग हो गया, मतलब वहीं पर खड़ा है वो कार। ठीक है, ईच मूविंग कार हैज द सेम स्पीड। और ये लाइन पढ़ के ही मुझे कुछ कुछ हिंट्स मिल गया था। ये वाला लाइन जो ना, कि हर कार का स्पीड सेम होगा, और ये लाइन मेरे लिए क्यों इंपॉर्टेंट था वो मैं आपको बताऊंगा। ठीक है, और क्योंकि इस तरह के पॉइंट्स हमेशा नोटिस किया, प्रॉब्लम स्टेटमेंट में जानबूझ के ऐसे लाइंस लिखे होते हैं, और मैं आपको अभी थोड़ी देर में बताऊंगा कि ये लाइन कैसे हेल्प किया मुझे। द नंबर ऑफ कॉलिजन्स कैन बी कैलकुलेटेड एज फॉलोस, व्हेन टू कार्स मूविंग इन ऑपोजिट डायरेक्शन। मान लेते हैं एक कार ये है, ये ऐसे जा रहा था, दूसरा कार ये है, ये ऐसे जा रहा था, क्योंकि लेफ्ट और राइट ही जा सकता है, तो ये दोनों ऑपोजिट डायरेक्शन पे कोलाइड करेंगे, तो इस केस में कॉलिजन का काउंट 2 होगा। ओके, और अगर इवन मूविंग कार कोलाइड विद स्टेशनरी कार, मतलब मान लेते हैं यहाँ पर कार खड़ा था, ये राइट हैंड डायरेक्शन में जा रहा है, इससे जब कोलाइड करेगा तब उस केस में आपको कोलिजन का काउंट सिर्फ 1 इंक्रीज करना है। ऐसा भी हो सकता है कि ये कार ये पे खड़ा हुआ है और लेफ्ट हैंड साइड जा रहा था, ये कार इसको हिट कर गया, तो उस केस में 1 काउंट करना है सिर्फ। मतलब अगर एक स्टेशनरी कार से कोलिजन होता है तो काउंट 1 होगा, अगर दो मूविंग कार अपोजिट डायरेक्शन में कोलाइड करेगा तो वो काउंट 2 होगा। ओके, आफ्टर अ कोलिजन द कार्स इन्वॉल्वड कैन नो लॉन्गर मूव एंड विल स्टे एट द पॉइंट वेयर दे कोलाइडेड। अब ये लाइन भी मेरे लिए इंपॉर्टेंट है, मुझे लगा क्योंकि इस तरह के पॉइंट लिखे हुए तो मतलब कुछ तो मतलब होगा, तभी तो यहाँ मेंशन है ना, इन चीज़ों को ध्यान देना। अदर देन दैट कार्स कैन नॉट चेंज द स्टेट और डायरेक्शन ऑफ मोशन, कुछ चेंज नहीं हो सकता, कांस्टेंट स्पीड है उनका, सभी कार का सेम स्पीड है, डायरेक्शन चेंज नहीं हो सकता। रिटर्न द टोटल नंबर ऑफ कोलिजंस दैट विल हैपन ऑन द रोड। ओके, जैसे ये एग्जांपल देखो, सबको मैं ड्रॉ कर लेता हूं, जैसे आर एल आर एस एल एल है ना, तो एक कार है जो कि राइट डायरेक्शन पे जा रहा है, ये लेफ्ट डायरेक्शन पे जा रहा है, ये राइट डायरेक्शन में जा रहा है, आर एल आर हो गया, फिर एस एस मतलब स्टेइंग हियर कांस्टेंट, इधर खड़ा हुआ है, ये लेफ्ट जा रहा है, एक कार लेफ्ट आ रहा है, ये कार भी लेफ्ट आ रहा है, तो देखो कितना कोलिजन होगा। सबसे पहले इन दोनों को देखो, ये दोनों अपोजिट डायरेक्शन में मूव कर रहे हैं, क्योंकि ये राइट जा रहा है, ये लेफ्ट जा रहा है, तो कोलिजन का काउंट कितना ऐड होगा इन दोनों की वजह से, इन दोनों की वजह से 2 कोलिजन काउंट होगा। ओके, और टकराने के बाद दोनों स्टिल खड़े हो जाएंगे, ठीक है, यहाँ लिखा हुआ है कि दे विल स्टे एट द सेम पॉइंट, दोनों स्टिल हो जाएंगे। अब इस कार को देखो, ये इस स्टिल वाली कार से टकराएगा, है ना, तो 1 कोलिजन काउंट होगा क्योंकि ये स्टिल कार से टकरा रहा है। ओके, जब टकराएगा तो दोनों स्टिल हो जाएंगे, है ना, दोनों एक जगह रुक जाएंगे। तो देखो ध्यान दो, दोनों एक जगह रुकेंगे तो ये तो इधर ही खड़ा रहेगा और ये भी टकराने के बाद रुक जाएगा। ओके, और उसके बाद देखो ये दोनों कार भी टकरा सकते हैं क्योंकि ये तो अभी भी स्टिल है, टकराने के बाद भी स्टिल ही रहेगा, तो इससे टकराएगा तो यहाँ पर 1 कोलिजन और ऐड हो गया। अब जब ये दोनों टकराएंगे तो दोनों स्टिल हो जाएगा। देखो इसका मतलब क्या हुआ कि ये वाला कार भी स्टिल हो जाएगा टकराने के बाद, ये वाला कार स्टिल हो जाएगा टकराने के बाद, इसका मतलब क्या हुआ कि ये भी इससे टकरा पाएगा फ्यूचर में, है ना, क्योंकि ये स्टिल हो जाएगा इससे टकराने के बाद। तो इसके मतलब क्या हुआ कि ये दोनों भी कोलाइड करेंगे, इसकी वजह से 1 कोलिजन होगा, क्योंकि ये तो स्टिल हो जाएगा ना, और स्टिल कार से कोलिजन में 1 कोलिजन काउंट करते हैं हम लोग। तो टोटल देखो 2 3 4 5, टोटल 5 कोलिजन काउंट हुआ, आंसर हमारा 5 है। ठीक है, तो देखते हैं थॉट प्रोसेस में कि मैंने कैसे ऑब्जर्व किया, प्रॉब्लम में क्या-क्या मैंने पढ़ा जिससे मुझे आसान लगा प्रॉब्लम। तो मैंने ये एग्जांपल लिया, ठीक है। अब देखो प्रॉब्लम में कुछ चीजें दे रखी हैं। पहला जो मेरे लिए सबसे इंपॉर्टेंट पॉइंट था कि सभी कार का स्पीड सेम है। अब एक बात बताओ, सिंपल सा मैं एक सवाल पूछता हूं, मान लेते हैं एक गाड़ी है,
Wait.
ठीक है, ये गाड़ी है, ये जा रहा है राइट हैंड डायरेक्शन पे, मतलब ऐसे जा रहा है। ओके, और मान के चलते हैं एक और गाड़ी है जो कि राइट हैंड डायरेक्शन पे जा रहा है, एकदम सेम गाड़ी है, राइट हैंड डायरेक्शन में जा रहा है। ओके, और इसका ये भी राइट हैंड डायरेक्शन में जा रहा है। मान लेते हैं इसका स्पीड 100 किलोमीटर पर आवर है, इसका भी स्पीड 100 किलोमीटर पर आवर है। अब मुझे एक सिंपल सा सवाल का जवाब दो कि यार दोनों कभी कोलाइड करेगा? जिंदगी में नहीं करेगा, क्योंकि दोनों का स्पीड एक्जैक्टली सेम है, तो इन दोनों के बीच डिस्टेंस है वो कभी कम होगा नहीं, क्योंकि दोनों कांस्टेंट स्पीड से जा रहा है, दोनों सेम। लेकिन ये राइट हैंड डायरेक्शन पे जा रहा है, मतलब इधर कंडीशन आ गया, अभी देखो दोनों राइट डायरेक्शन में जा रहा है। जो बाउंड्री की बात करें, तो राइट हैंड साइड मैं पूछूं क्या राइट है, राइट डायरेक्शन में जा रहा है, इधर पे जा रहा है, नहीं तो मैं यहीं पर रुक गया, नहीं चले जाएंगे, कभी कोलिजन होगा ही नहीं उधर कभी। ओके, ठीक है, अब आते कर दीजिए तो 2 कोलिजन होगा, 1% दैट इज 2, है ना। और एक्चुअली में 2 कोलिजन पता है क्यों काउंट कर रहा है, एक इसकी वजह से हुआ कोलिजन, एक इसकी वजह से, मतलब दो कारें टकराई इसलिए 2 कोलिजन काउंट कर रहा है। ठीक है, तो अब जैसे मैं यहाँ पर मैंने देखा चाहिए राइट हैंड डायरेक्शन में मतलब कोलिजन तो होगा, तो मैंने क्या बोला कि ये कार है ना, इसकी वजह से 1 कोलिजन मैं काउंट कर ले रहा हूँ, क्योंकि मुझे अभी नहीं पता आगे जाके एक स्टेशनरी कार से टकराएगा या फिर लेफ्ट हैंड साइड में आने वाली कार से टकराएगा। ठीक है, तो मैंने इसका 1 काउंट तो कर दिया कि 1 कोलिजन तो इसका मैं काउंट करूंगा ही करूंगा, क्योंकि ये कोलाइड करने वाला है। ठीक है, तो मैंने आई को आगे बढ़ा दिया, है ना। अब ये लेफ्ट जा रहा है, तो ये लेफ्ट जा रहा है, तो मुझे गारंटी पता है किसी ना किसी से कोलाइड करेगा ही करेगा, यहाँ पर लेफ्ट हैंड साइड में किसी से कोलाइड करेगा। तो अब मुझे ये नहीं पता किससे कोलाइड करेगा, स्टेशनरी से करेगा या फिर एक मूविंग राइट हैंड साइड में आने वाला किसी कार से कोलाइड करेगा। तो मुझे इतना पता है कि ये तो कोलाइड करेगा, तो मैंने इसका +1 कर दिया। अब देखो ध्यान दो, एक्चुअली में ये कार और ये कार कोलाइड करने वाले थे, है ना, ये राइट जा रहा है लेफ्ट जा, तो कोलाइड करने पे कितना, दोनों अपोजिट डायरेक्शन में मूव कर रहे हैं। प्रॉब्लम में दे रखा है कार अपोजिट डायरेक्शन में कोलाइड करते तो 2 आपको ऐड करना है कोलिजन में। देखो मैंने ऑटोमेटिकली 2 ऐड कर दिया। एक बार जब मेरा आई पॉइंटर यहाँ पर था तो मुझे नहीं पता था किससे, और एक्चुअली में सही बात है, ये दोनों कार कोलाइड करेंगे अपोजिट डायरेक्शन में करके, तो कोलिजन 2 ही होना चाहिए, तो यहाँ पर 2 है। यहाँ समझ में, ठीक है, बहुत सिंपल तरीके से मैं सिमुलेशन कर रहा हूँ एक्चुअली, सिमुलेशन ये लेफ्ट हैंड साइड में आने वाला किसी ऑब्जेक्ट टकराएगा, मुझे पता है कि ये टकराएगा, तो मैंने उसकी वजह से एक +1 मार्क कर दिया कि एक कोलिजन तो हो गई होगा। ठीक है, अब आई जब मेरा यहाँ पर आया, मैंने देखा स्टेशनरी ऑब्जेक्ट है, तो याद करो ये स्टेशनरी ऑब्जेक्ट से कौन टकराएगा, इसका मतलब, है ना, और सिंस स्टेशनरी ऑब्जेक्ट है तो टकराने पर 1 ऐड करना था, इसलिए मैंने 1 ही ऐड किया। ठीक है, तो आई ऑब्जेक्ट तक हो गया, मतलब हमने सारे को प्रोसेस कर लिया, और एक्चुअली हमारा आंसर 4 है, 4 कोलिजन पॉसिबल है इसमें। ओके, तो आपने नोटिस किया इस तरह लीनियरली इटरेट करने पर भी हम आराम से दोनों केस कवर कर पा रहे हैं कि भाई अगर अपोजिट डायरेक्शन वाला कोलिजन होता है तो मुझे 2 ऐड करना है, एक मैंने राइट हैंड डायरेक्शन है, ये लेफ्ट हैंड डायरेक्शन आर को जब मैंने प्रोसेस किया था, आई पॉइंटर जब मेरा इस आर पर था तो मैंने 1 ऐड कर दिया था, तो ये कोलिजन 1 ऐड होगा। सिमिलरली स्टैटिक अगर एल डायरेक्शन पे कोई आ रहा है तो इसके लिए मैंने 1 ऐड किया था, है ना, आई पॉइंटर यहाँ है तो मैंने 1 ऐड किया था ना, तो ऑब्वियस बात है यहाँ पर एक ही कोलिजन होगा क्योंकि स्टैटिक और स्टैटिक टकरा रहा है। ठीक है, तो आई पॉइंट एक सिंगल इटरेशन से प्रॉब्लम बहुत आसानी से सॉल्व हो गया, बहुत सारे तरीके से बनाने के, स्टैक की मदद से भी सॉल्व कर सकते हो, बट उसकी जरूरत नहीं लगी मुझे, काफी सिंपल स्ट्रेट फॉरवर्ड सॉल्यूशन। ओके, तो अगर आपने नोटिस किया होगा मैं सिंपली आई को कहां से कहां तक मूव कर रहा हूं, हैंड लेफ्ट बाउंड्री में एल को स्किप कर दिया, राइट बाउंड्री में आर को स्किप कर दिया, तो आई मेरा यहाँ चुका था, जी मैं यहाँ चुका था। अब वाई आई लेस देन इक्वल टू जी कर रहा हूँ, है ना, एक एक आई मूव कर रहा हूँ, और जो है लेस देन इक्वल टू स्टैटिक और स्टैटिक टकरा रहा है। ठीक है, तो आई पॉइंट एक सिंगल इटरेशन से प्रॉब्लम बहुत आसानी से सॉल्व हो गया, बहुत सारे तरीके से बनाने के, स्टैक की मदद से भी सॉल्व कर सकते हो, बट उसकी जरूरत नहीं लगी मुझे, काफी सिंपल स्ट्रेट फॉरवर्ड सॉल्यूशन है। ओके, तो अगर आपने नोटिस किया होगा मैं सिंपली आई को कहां से कहां तक मूव कर रहा हूं, वाइल आई जो है लेस देन इक्वल टू जी तक जा रहा है ना, तो आई को जी तक ले गया। हाँ, उससे पहले मैंने ये कर दिया था, ये वाला पार्ट आई को लेफ्ट बाउंड्री में एल को स्किप कर दिया, राइट बाउंड्री में आर को स्किप कर दिया, तो आई मेरा यहाँ चुका था, जी मैं यहाँ चुका था। अब वाइल आई लेस देन इक्वल टू जी कर रहा हूँ, है ना, एक एक आई को मूव कर रहा हूँ, और मैं सिंपल यहाँ पर ये चेक कर ले रहा हूँ कि इफ मेरा जो डायरेक्शन स्ट्रिंग है अगर वो इक्वल टू एल है या फिर मेरा जो डायरेक्शन इक्वल टू आर है, एल हो चाहे आर हो, तो मैंने क्या बोला, मैं सिंपली क्या कर रहा हूँ, कोलिजन का काउंट में +1 कर दे रहा हूँ। यही मैं कर रहा था यहाँ पर, देखो आर दिखा तो +1 किया, एल दिखा तो +1 किया।
Are you a
आर, ठीक है, इस कंडीशन को टाइम क्वांटिटी क्या है, सिंपली ऑफ एन है, क्योंकि हर कैरेक्टर को मैंने एक बार ही विजिट किया, आई पॉइंटर कोलिजन का काउंट एल और आर दिखा तभी मैं +1 कर रहा हूँ। देखो आर दिखा तो +1 किया, एल दिखा तो +1 किया, फिर आर दिखा तो किया यहाँ स्टैटिक देखा प्लस वन नहीं किया, क्यों नहीं किया, क्योंकि ये आई से टकराएगा ना, तो उसका प्लस वन मैंने ऑलरेडी यहाँ कर दिया था ना, ठीक है। और स्टैटिक को मैंने स्किप कर दिया था, फिर यहाँ पर आया तो प्लस वन किया। देखा जाए तो बस एल और आर दिखा तभी मैं प्लस वन कर रहा हूँ, नहीं तो कर ही नहीं रहा हूँ प्लस वन, है ना। आई प्लस प्लस करते चले जाना, लास्ट में रिटर्न क्या करना है, ओरिजिन का काउंट, ठीक है। इस यहाँ कर दिया था ना, नहीं तो कर ही नहीं रहा हूँ प्लस वन, है ना। आई प्लस प्लस करते चले जाना, लास्ट में रिटर्न क्या करना है, ओरिजिन का काउंट। सिंपल सा कोड था देखो, ओके। टाइम क्वांटिटी क्या है, सिंपल आर हो, या फिर इसको सिंप्लीफाई करके आप ऐसे भी लिख सकते थे कि अगर डायरेक्शंस ऑफ आई नॉट इक्वल टू एस है, नॉट इक्वल टू एस मतलब वो क्या हुआ कि या तो वो एल रहा होगा या तो आर रहा होगा, उस केस में मैं प्लस वन कर रहा हूँ, बस एस वाले को स्किप मार रहा हूँ, तो नॉट इक्वल टू एस में प्लस वन कर दो, दैट्स इट। इतना सिंपल सा कोड था देखो, ओके। टाइम क्वांटिटी क्या है, सिंपली ऑफ एन है, क्योंकि हर कैरेक्टर को मैंने एक बार ही विजिट किया, आई पॉइंटर ऐसे ए लिनियरली तो इटरेट हुआ है। टाइम क्वांटिटी ऑफ एन है और स्पेस क्वांटिटी ऑफ वन, क्योंकि मैंने कोई भी एक्स्ट्रा स्पेस नहीं लिया। जल्दी से कोड करते हैं, इसको फिनिश करते हैं। डायरेक्शन डॉट लेंथ ऑफ आई इज इक्वल करेंगे व्हाइल, है ना, इंट कोलिजंस का एस, अगर स्टेशनरी वाला कार नहीं,
This is pretty simple, but okay. I solved it by my method as well, but this was a pretty good solution as well. Yeah. Mm. Push. Mm. Okay. This is a much better and efficient solution for this problem. Okay. Oh, okay. What is this? Okay. We have a int I equal to 0 and j equal to n minus 1, where int n equal to direct dot length. Oh, char array char dir is equal to new char. Oh no, directions dot to char to char array. Hmm. Oh, okay. So while I is less than n, while I is less than n and dir of I is not equal to uh is equal to L, we increment the ith pointer, and while j is greater than equal to 0 and dir of j equal to r, we decrement j. While I is less than equal to j, we perform these following operations. If dir of I is not equal to s, then we basically collision equal to 0. Then we increase the value of collision by 1, right? And then just simply return collision. Oops. Hmm. And then increment I. This should work. Perfect. Yeah, it's pretty efficient, of course. It's a of one solution. Great. Okay. Okay, so I wanted to solve this problem. Total waviness, right? Total waviness. This is a hard problem asked recently in bi-weekly contest 170. It requires digit DP. This question motivated me to learn digit DP. Let's see if I'm able to solve this problem or not. But before that, I need to take a break. Okay, I'm back. Let's solve some problems. Mhm. Okay, I'm live. This is me trying to solve question 3753, total waviness of numbers in range 2. You are given two integers num1 and num2 representing an inclusive range num1 comma num2. The waviness of a number is defined as the total count of its peaks and valleys. A digit is a peak if it is strictly greater than both of its immediate neighbors. A digit is a valley if it is strictly less than both of its immediate neighbors. Okay. The first and the last digit of a number cannot be peaks or valleys. Any number with fewer than three digits has a waviness of 0. Okay. Okay, so let's think, what states do we need? What are the different states we require? What are the different states? First, is obviously index. Second is tight. Third is the leading zeros. We do need leading zeros. We basically check the condition of leading zeros. We also need a fourth state, which will have the previous digit as a p if it is. Hmm. We have previous, and then we also need a fifth state, which is previous of previous, so that because we have the current index, we have the previous, and we have the previous of previous, right? So what does this mean? Like we can check or put a condition for just a minute. We can put a condition for previous and check if both the digits, that is the current and the previous is greater, that is if it's a peak, or if both are less, which is it is a valley. If it's peak or a valley, what do we have to do? Okay, digit is okay. We increment the number by 1. Okay. So we need to find different values which are peak. Okay. So this is a peak, this is a valley. So the value is 2, output is 2. Okay. So we need to create all the possible numbers and check if the adjacent elements or the digits are greater, then we increment by 1. If it's smaller, then we increment by 1. Hmm. Obviously, the numbers are till 10 power 15. Okay. Let's return solve of S, and side by side create our solve function, public long solve string S. We have index, we have tight, we have a leading zero, then the previous digit. It should be the previous digit. This should be integer value, right? Because it cannot exceed, it will be from 0 to 9. Okay. And we have int previous. Index, starting index is 0. Type is true, leading 0 is true. Previous. Now this is the tricky part. The thing is, previous can be from 0 to 9. So we can just set it as an invalid value, which is 10, and previous of previous, which is 10. Hmm. Okay. If IDX equal to s dot length, we'll see what happens. Int during int lower bound is 0, upper bound is also 0. Oh, sorry. Upper bound is we check the condition if type is true, then s dot char at IDX this, otherwise we return 9. This, otherwise we return 9. Otherwise, as we check the condition if type okay. Hmm. Okay. Hmm. We iterate over all the possibilities, lower bound, digit less than equal to upper bound, digit plus plus. Okay. Hmm. Now if we have a leading zero and digit equal to 0. If we have leading 0 and digit equal to 0, we continue. Continue, or rather, just call this as idx plus 1. Type will be true, leading 0 will be true, previous will be previous, and previous will be previous. How do you handle the previous condition? That is the tricky part. Okay,
Won't works.
let's see the solution.
We'll look at the fourth problem. So
Oh, we also need to keep a track whether the previous number was small or not. But do we need to keep a track? Hmm. We also need to keep a track of this basically the count. We need to send a parameter count, int count. In the starting, it's going to be 0. But let's see. If this is equal, return count. int result equal to 0, return result. Let's see. And this, hmm. If it's a leading 0, just move on. Just basically continue. But if that's not the case, then we need to check a few conditions. Okay, anyways, what will be the condition? Hmm. We need to check. We need to first initialize new previous, which will be equal to this. Initialize new previous, which will be equal to previous. And we know the current state because we will increment the index or IDX. If let's say int new sum equal to sum, or basically count, new count, no, no, uh, equal to count. If previous is less than, it's strictly okay, strictly less than uh the current, what is this, digit, then the current digit, and previous is also less than the current digit, then new count plus plus. If previous is greater than the current digit and previous is greater than the current digit, and oh wait, we need to check if okay, wait, if previous is less than previous, and if the current digit is also less than previous, then increase the count. If previous is greater than previous, and if the current digit is also greater than, if the current digit is also greater than previous, which means this is a peak, uh this is a valley. Now in the result, add solve function s idx plus 1 increment to the next index. The tight condition, we can check the tight condition. If tight is true and if the current digit is equal to upper bound, tight will be set to true. else it will be set to false. For leading zeros, hmm, in a Boolean new leading zero equal to, just check this condition. If this is true, set it to true, else false. New leading zero. So need to write an else condition as well there. Okay. New leading zero. Hmm. New leading zero. Okay. Then we count previous. This will never be this. This can be. This will be always bigger. Okay. New leading zero. Then we send new previous, and then the new count. Here we return the count. Okay. If it is a leading zero, what do we do? Yeah, just result plus equal to solve s idx plus 1. Type will be true. Leading zeros will be true. Previous will be previous. Yeah. This will be previous. New previous. Oh, previous will be previous. And count will be count. That's it. Hmm. I believe this should work. Oh yeah. We do need to check this. Yes, this is an important condition. I was mainly confused because of this condition. What should we do? But now I understand. But now, why do you need small variable? Where have you used this variable small? Okay, anyways. Hmm, this is an important condition. If previous is not equal to 10 and previous is also not equal to 10, that's when we execute this condition. And I think we should be good. This minus this. This is a long value, I believe. Yeah. If I convert nums, this is num2, this is num1. I can convert nums1 from long dot to string long dot value of what's this num1, and then just decrement it by 1 or subtract it by 1. Whatever. Let's go. Oh, this will be IDX. Oh, this will be digit. My bad. If I don't know. Okay, let's see if this works or not. Good. Wait, wait, wait. We already have. Oh my god. We can directly decrement the value here itself. Oh, long dot to string long dot to string. Uh, it's a TLE case. Okay, I'm off by 1. Did I not put a equal to sign? I did put a equal to sign. This minus this. One, then 2. Hmm. Okay, so as the length of the number increases, it's giving wrong answers. It's giving wrong answers. Okay. 4, 8, 2, 5. Let's see. And 2, 5. Yep. As soon as the numbers increase, we get a wrong answer. Also, what if I do this? Oh, oh, my bad. Hmm. Okay, let's try and understand this problem.
This fourth problem is
Solution.
a digit DP problem. Again, digit DP. I don't know whether you notice or not, but in last 4 or 5 contests, I always see one digit DP problem. So yeah, let's see how we can solve it. So to solve this problem, again, I'm going to explain it through the code itself, because I mean, personally, I feel, I mean, digit DP is not very straightforward. So I mean, I generally feel like explaining through code is easier to understand, at least in DP problem. So, and especially digit DP. So yeah, let's see what I'm doing here. So I hope you know what was the problem statement. So we have to find out all like the total waviness for all the numbers between num1 to num2, right? So num1 to num2. So for to calculate that, I created a function, count function. So one thing, if you want to find out waviness from the numbers num1 to num2, let's say I created a function count, right? This count function will tell you, let's say you pass x value, right? Count of x. So count of x will tell you total number of waviness from integer 1 to x. Let's say this count function gives you the total waviness from integer 1 to x. So to find out the waviness from num1 to num2, we can easily do count num1 to num2 minus count of num1 minus 1, right? Because to find out, so see, count of, and let's say there is somewhere here num1, and if you want to find out what this count function does, first if your number is 0 itself, just return 0, right? Otherwise this d would tell you the decimal representation of the number passed. So let's say the number passed is 1543, right? Let's say this is the number you passed, right? So d would be a vector that would store 1, 5, 4 and 3, right? Because in digit we want to play with digits, right? So it's better to store all this digit information into some vector. So it's a pretty standard implementation. While x is not equal to 0, just insert the last digit, then divide x by 10, then reverse it, right? So since we are going from LSB to MSB, so initially the vector would store 3, 4, 5, 1, right? So just reverse it, you would get 1, 5, 4, 3, right? So reverse of it. Now in DP problem, we know we create a DP. It's a standard top-down DP. So create a DP, then memset DP. So initialize with -1 and then call this function, right? So I hope you understand this part. Now let's see what this solve function does. This solve function is very important. Actually, when I was writing the code, I mean, it took me some time to figure it out, so each and every state. So I'll explain everything for you. So this solve function takes a couple of arguments. So position, sum, previous is small, and ng, non-zero. Let's see what this position is. Position is nothing but, so in the example when we had 1, 4, 5, 3, for example, right? So this d would store 1, 4, 5, 3, right? So this position is the position, like at which position you are currently. The sum here, the sum is nothing but count of all waviness, so far, right? So this sum is nothing but the sum of the count of all waviness so far. Previous is nothing but, so this is my position, right? So let's say this is my position, this is my current position. Previous to and previous is nothing but previous number, like the previous digit, and previous of previous digit. So this is PRV2 and this is PRV, right? So previous and previous of previous. So because we know that we have to take care of 3 numbers at a time, otherwise we cannot make a decision of peak and valley, right? So to find out whether current position, previous digit, and previous of previous digit is small here. Now small will tell you if whether the digit which you are going to form is smaller than x or not. That's it, is smaller than x or not. And g will tell you if whether the digit which you are going to form is smaller than x or not. That's it, is smaller than x or not. Now small will tell you if whether the digit which you are going to form is smaller than x or not. That's it, is smaller than x or not. And g will tell you if you have any non-zero digit so far, like if you have any non-zero digit so far. That's it. So this is all about the arguments. So these many arguments would be required in order to solve this problem. Now let's see what I'm doing here. So if your current position is d.size, so we know that this d.size is nothing but, so for example 1, 4, 5, 3, here d.size is 4, right? So if your current position is already equals to 4, then just return it, right? Like return the sum, because we know that the position is going to be from 0 to n minus 1, right? So 0 to 3, because it's a 0 wave index. So if your current position is itself is 4, means that you have already so you have return. So we know that would be required. So this is all about the arguments. So these many arguments would be required in order to solve this problem. Now let's see what I'm doing here. So if your current position is d.size, so we know that this d.size is nothing but, so for example 1, 4, 5, 3, here d.size is 4, right? So if your current position is already equals to 4, then just return it, right? Like return the sum, because we know that the position is already equals to 4, then just return it, right? Like return the sum, because we know that the position is going to be from 0 to n minus 1, right? So 0 to of all the digits from index 0 to 3, right? So this is that part, and this is the standard implementation. If your DP of position, sum, previous to previous, small n g is not equal to -1, like so the DP value already calculated. Out the limit, so we know that we are going through each of the position, right? Position from 0 to this number of digits -1, let's say m -1, right? We are going through each of the position. So each position we would be keeping some digits, right? So let's see what is the limit of this digit. If your digit which you are going to form is already smaller than, so it means if your digit which you are going to form is already smaller than x, then we can keep any of the digit at the current position, right? So let's take one example. Let's say in 1 4 3 1 4 5 and 3. Let's say you have already, so you are at position here and you have kept 1 and 3 before. See, if you have 1 and 3 before of it, means that whatever digits which you keep at this position, the number is always going to be smaller than this, right? So in that situation, what is the limit? Limit is, and you have to take one example. Let's say in 1 4 3 1 4 5 and 3. Let's say you have already, so you are at position here and you have kept 1 and 3 before. See, if you have 1 and 3 before of it, means that whatever digits which you
Oh, small is basically the tight in our
keep at this
case. Okay.
position, the number is always going to be smaller than
1, 2, 3, 4, 5, 6. 6 states, like 1, 2, 3, 4, 5, 6. Perfect.
this, right? So in that situation, what is the limit? Limit is 9. That will the overall digit is, the complete digit is always going to be smaller than x, because you cannot keep 6 here, because 1 4 and 6. See, this is my answer. It's exactly same as the original digits, right? Original digit in the present in the x. So either you already have is smaller. If you don't have, just check if your current digit ith digit is less than 5 or not. If the current digit which you are going to keep here is less than 5, means that now it becomes small, right? Otherwise, it's going to be small, or I is less than d of position. Similarly, non-zero, new non-zero, this n means new value, right? New non-zero is going to be either already you have non-zero, or your current I is not equal to 0, right? So this will give you the new non-zero. Now simple one if condition. Let's take the else condition first. That is easy. If you have if new non-zero is 0, means that all the digits are 0. In that situation, just call the function solve function. Next position, new non-zero is 0, means that all the digits are 0. In that situation, just call the function solve function. Next position, sum, right? So sum is not going to be changed, right? Because you already have 0 0 0.
Basically, if we have leading zeros, new leading zeros, if this is true, sorry, yeah, this is true, then go here. We increment the index and everything. This is set to true. Some, okay, let's
0 0
see.
everywhere. Sum.
What's up?
Previous to previous is small, and new non-zero. Everything is going to be same, right? No change. But if your new non-zero is positive 1, right? It means that you have at least one non-zero digit so far. So in that situation, just check if you can find out whether the current digit is peak or value, So here what I have done. One interesting thing is that to handle the case when we had just one digit, right? So let's say I have 1 4 and I am here, right? If you are here, if this is your position, here you have just 2 digits, right? So we cannot handle, so we can digit is just check if you can, everything is going to be same, right? No change. But if your new non-zero is positive 1, right? It means that you have at least one non-zero digit so far. So in that situation, just check if you can find out whether the current digit is peak or value.
Value. नाही मी नाही केली. Hmm. Hmm. Nice. Hmm. Is greater previous system. This is less previous system.
your sum is. So just increment your sum. If it's a peak, increment this count. If it's a valley, increment its count. And once you calculate this new sum, just call the solve function for next position, next sum, like next position, new sum, new previous two. So one interesting thing is, see, if you have so at position I, right? Sorry, not position I. At this position you have digit I. This was your previous digit, and this was your previous of previous. But once you go to next position, position plus one. Now this would be your new previous, right? This would be your new previous, and this would be your new PRV2. That's why your new PRV2 is going to be previous. Now new previous is going to be I, and new sum is already calculated. And then call this solve function for position plus one, new sum, new previous two, new previous, and new small and new non-zero. That's it. And at the end, just do a regular, I mean standard DP of return DP.
Oh. Oh. Hmm. This is new previous. New previous is digit. New previous of previous is previous. Why is this wrong? This is my neck. Not good. No. थोड़ा सा हाँ
तुला झालं असं असं झालं हा काही गोष्ट होणार ना ठीक आहे हा नाही बस म्हणून मी तेच बघितलं कॅमेरा नाही बस नाही नाही बस
Want to keep digit I know what is my previous digit. Previous digit is PRV. What is previous of previous? That is nothing but PRV2. Now to check whether there is a peak or valley, we can check if the previous digit is, if it's a, go to next position plus and new small and new non-zero. That's it. And then just do a regular into forward. So just spend some time, write this code up by yourself. So I would recommend to watch the video as well as parallelly write your code, like write the code in your editor. Then you would understand it better, right? If you just watch the video, you just forget everything. So it's better to write the code along with watching the video. That would help you to kind of grasp everything in a best way. Yeah, that's it about this fourth problem. If you find the video helpful, please like, share and subscribe to my channel. And I have also made it the video of first three problems, so you can check it out that also, right? Yeah, thanks for watching.
Hey everybody, this is Larry. This is... I'm so tired. I'm always tired. Day 4 of the LeetCode December Day Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about today's problem. Today we're trying to 11 count collisions on the road. Okay, yeah, let's count. I have nothing to say. Gotta just have a rest day. Because these days, every weekend I've been doing stuff, and weekday I've been just also doing stuff. So I need like a rest day where I just literally do nothing. Maybe next week. Because this weekend I'm going to see penguins. More on that later, hopefully. But anyway, let's take a look at today's problem. We're trying to 11 count collisions on a row. There are n cars on an infinitely long row. The cars are numbered 0 to n-1 from left to directions of I could be left or right, or S, like staying. Okay, so S is just not moving. Same speed. Okay. Number of collision is when two cars move in the opposite direction. Number of collision increases by 2. With a moving car, collision stays. Right? After collision, the cars involved can no longer move and will stay at the point where they collide. Other than that, the cars cannot change their state or direction of motion. All right, so it seems like a simulation E problem. I mean, N is pretty big, so you probably have to be a little bit smart about simulation. One thing that I will do right now is look at an example because I'm not quite sure what they mean by no longer move and stay at the point where they collide. Because does that mean like other stuff can collide later, or okay, right? Because 0 and 1, these things collide. Okay, and R collides with S collides with L collides. Okay, I mean, this makes sense, right? 2 and 3 will collide. S and L will also collide. 4 and 5. Okay, so that's the part that I wasn't clear about from reading the bar. After 4 collides with 3, and then get hit by 5. Okay, but when 0 and 1 collide with each other, where are they? They stay at 0 and 1? What is the point of collision? The point of collision is at the S, I guess, in this one. But what's the point of collision of L and R? This is a little bit, I mean, I don't know. It's just not very clear what... It's not quite clear where they do it, but maybe it doesn't matter, right? But I'm just curious why. Yeah, okay, fine. Still just trying to find what I call an invariant. It's not, well, I don't mean to suggest I'm the only one that calls it that, but where it does not, because two S's will never collide with each other because they both are not moving. L and R will always have +1, right? The only thing that doesn't give you a +1 each, because if an L or an R collides with each other, then it's 2. If an L and R collides with an S, then it's +1. So each L is +1 and each R is also +1. Except for, well, in example 2, right? Where you have on the edges going to the right and going to the left. So I think that's it, right? You just count the number of L's and R's, you subtract it from the number of L's on the left side and R's on the right side, and I think that's it, right? I think so. I guess we'll see. If not, then for me, I'll just do them like this. The number of prefixes of L, right? Yeah, so then I mean, I know how to write check for prefix, of course. I'm just trying to think whether there's like a clever Pythonic way of doing it, but maybe not. Maybe there is, maybe there isn't. I don't know. But for C in directions, right? So if C is not equal to L, then we break else. We subtract 1, right? Because it's escaping, and then we do the same thing in the opposite directions. We count backwards. If C is not equal to R, we break. Otherwise, we subtract 1, and then we C, right? YOLO submit, and there you go. Yeah, okay. Went better than expected, which is what I needed because I was so tired yesterday. Oh yeah, I was going to do a quick intro of something. I haven't done anything interesting lately, but I wanted to show an image of... Yeah, can you see that? Amazon screen? Yeah, so this is... I mean, I guess this is an extra more than an intro. But yeah, this is my photo from whatchamacallit? From El Chatan, First Void, Patagonia, whatever you want to say. It's so I don't know, it looks pretty good if you ask me. Okay, maybe not your pixel peep. But in any case, I don't know. I don't have a fancy intro. Maybe I should. Maybe I'll do it again tomorrow. So if you see it again tomorrow, it's because I've got to do it as an intro. But yeah, I hope you enjoy it. I think there's a version with me in it, but without the good light because I don't know. Maybe I don't know. Is it worth it? In any case, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye. Oh wait. I forgot to do complexity. I always forget, kind of, because for problems where it's not that interesting. This is linear time, constant space, right? That's why I mean I definitely should be more proactive about it, but it's just something that like when I saw n is big, I knew that if we can figure out either linear or n log n type thing, they'll be fast enough. But of course, if it's linear, then I don't have to really look at n, right? I look at this, it's linear, it's all one space. I don't have to see if it's fast enough because that's the lower bound usually, right? I mean, not always, but for LeetCode purposes, if you could do better than linear time, it rely on this input structure to be something different, or like pre-processed or whatever. But anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye.
And people in the programming contest chat participants are ordered by activity. and their order is 2314, this is some kind of order. It doesn't matter that which type of order it is just a random order which is given. Then the first user sees this, for example. So hi everyone, so today in this video we will be discussing an interesting code forces problem from code forces round 925 div 3, and it is rated 1700. The problem goes by the name chat screenshots. So what does this problem say is, there are n people in programming contest chat. Chat participants are ordered by activity, but each person sees himself at the top of the list. What does this problem say is, there are n people in the programming contest chat. Chat participants are ordered by activity, but each person sees himself at the top of the list. For example, we are given with n equal to 4. That is, there are 4 people in the chat, and their order is 2314. This is some kind of order. It doesn't matter that which type of order it is just a random order which is given. Then the first user sees this order, second user sees this order, third user sees this order, and fourth user sees this order, right? So every user will see himself or herself first at the beginning, and then the remaining from this given order, right? So out of this n people, so every user will see himself or herself first at the beginning, and then then the remaining from this given order, right? So out of this n people, k people decided to post this screenshot of their order, which is visible to them, right? Which shows the order of participants shown to this user. The screenshots were taken within a short period of time, and the order of participants has not changed. So our task is to determine whether a certain order is possible from these given orders or not, right? For example, if we consider the same test case, so let me explain you in this board, right? So we are considering this example. So here n is equal to 4 and k is equal to 4, and also our k can be less than or equal to 1, right? So here n and k are same, and the orders given are 1 2 3 4, 2 3 1 4, 3 2 1 4, and 4 2 3 1, right? Okay, this is given to us, right? And we have to determine whether a valid order is possible to be deduced from this given orders or not. So according to the first user, so according to this user, 2 should come before 3, and then 3 should come before 4. So 2 should come before 3, right? 2 should come before 3, and 3 should come before 4. Fine. Then according to the second user, which posted his screenshot in the chat, according to him, 3 should come before 1. Okay, 3 should come before 1. That means 1 will be present either here or either here. And 1 should come before 4. So 1 should come before 4. So 1 must be present here, right? So let me write down this clearly. So 1 will be present here and 4 will be present here. Now according to the third user, 2 should come before 1 and 1 should come before 4. So 2 is coming before 1. Okay, and 1 should come before 4, which is good. Now according to the last user, 2 should come before 3. Okay, 2 is coming before 3. And 3 should come before 1. So 3 is also coming before 1, which is fine. So when we try to deduce a possible order out of these given orders, we do not face any type of contradictions, which means that this is a valid order, right? This is a valid order. So where does this problem is hinting towards? If you see, then what we wanted is, we wanted that 2 should come before 3, 3 should come before 4, 3 should come before 1, 1 should come before 4, right? So this is pointing towards a topological sort problem, or topological sort solution rather, right? So what we will do is, to check if a valid order is possible or not, we will direct the edge from this to this. So here, it would be like, we will direct the edge from 2 towards 3, and then from 3 towards 4. Similarly from 3 to 1, and then from 1 to 4, right? Then from 2 to 1, and then from 1 to 4, which is already done. Then at last 2 to 3 and 3 to 1. 2 to 3 done, and 3 to 1 is already done too, right? So we have constructed this graph, right? So if you observe carefully, then there is no cycle present in this graph, right? There is no cycle. So this is an acyclic graph, right? This is an acyclic graph. And where do we observe acyclic graph? We observe acyclic graph in the condition of topological sort. We know the condition for topological sort is. What is the condition for valid topological sort? So if we want a valid topo sort, then the given graph should be DAG, right? That is directed plus acyclic, right? Directed plus acyclic. So this graph is directed, okay, and it is also acyclic, which means that this graph can have a valid topo sort, which is this one. This order is a valid topo sort, right? Okay, this order is a valid topo sort, and if a valid topo sort is possible, we just have to print, I guess yes or no. Yes. So if a valid topo sort is possible, we just have to print yes. So for this test case, the answer would be yes, and if it is not possible, then we will print a no. So let's consider an example where a valid topo sort will not be possible, right? So consider this example where this one, where n is 3 and k is also 3, and the screenshots of the users given are 132, 213, 321, right? So according to this, there are 3 users, right? There are 3 users. So according to this user, 3 should come before 2. 3 should come before 2. Okay, so we'll direct the edge from 3 to 2. Also 1 should come before 3. Okay, 1 should come before 3. So we'll direct the edge from 1 to 3. So we'll direct the edge from 3 to 2. Also 1 should come before 3. Okay, 1 should come before 3. So we'll direct the edge from 1 to 3. And at last 2 should be directed to 1, or rather 2 should come before 1 according to this user. 2 should come before 1, but here 1 has already came before 2, so it is not possible to make 2 come before 1. And if we try to observe the same thing in form of graph, then we will realize that we have to direct the graph from 2 to 1, right? So we direct the graph from 2 to 1, and clearly here a cycle is getting formed. This is a cycle from 1 to 3, 3 to 2, and 2 to 1. So this is a cyclic graph, and since it is a cyclic graph, then a valid topo sort for this graph will not be possible, right? Valid topo sort is not possible for this graph, and since a valid topological sort will not be possible for this graph, we will print no. So this is all that this problem asks from you, right? So coming into the coding part, so we have to take the inputs of n and k as mentioned in the question, and we want to take the input for k screenshots, right? And each k screenshot will have n integers, so we will be storing these n integers in a vector, say name screenshot, right? It represents an individual screenshot, right? After the input of each screenshot is done, we will push it towards a bigger screenshot that will collect all of these smaller screenshots. Screenshot that will collect all of these smaller screenshots. After the input of each screenshot is done, we will push it towards a bigger a vector, say name, and each case screenshot will want to take the input for case screenshots, right? And each case screenshot will have n integers, so we will be storing these n integers in a vector, say name screenshot, right? It represents an individual screenshot, right? After the input of each screenshot is done, we will push it towards a bigger screenshot that will collect all of these smaller screenshots. So let me declare it here. So it will be vector of long run because it has to store all of the individual screenshots. Right. So now after the input has been done, okay. So now the input has been done. So what we want to do now is we want to construct the graph using this input, right? So for this we will be using an adjacency list. Right, we will be using an adjacency list. I will be using one based indexing here also, and we will be iterating through each of the screenshot that is present in this bigger screenshots, right? Right. So this bigger screenshot of the using an adjacency list, I will be using one based indexing here also, and we will be iterating through each of the screenshot that is present in this. Bigger screenshots, right? Right. So this ID represents a bigger screenshot. Small typo here. Right. Okay. And going through each of this integer from one based indexing, as I told that we do not need to do anything with the first integer. We need to start from the first index, right, till the last index. So the same thing I will be doing here. And since its size is n, we know, so we'll just do n minus 1 so that we can direct the edge from u to v. And just to make sure that the same edge is not present between the two nodes, again I will do a check, rather
Can't trust.
using this if condition will ensure that if an edge is present between two nodes, then again a new edge will not be constructed, right? So I will direct the edge from this u to this v, it of I plus 1. Right? Once this has been done, once the graph has been constructed successfully, I will be using the concept of visited and path visited to check the cyclic condition, right? So we will use two arrays, namely visited, and I will also be using one based indexing here only, and path visited, right? So now I just have to go through each of the node and see if it is not visited, then I will call the DFS function, right? If this DFS function is true, and then I will return Okay, so hi everyone. So today in this video we are going to solve this problem from CACS problem set that comes under the sliding window section, and this problem has been added very recently, and the problem name is sliding window sum, right? So let us start with this problem now. So the problem
Nice. Okay.
Problem reads like this, that you are given an array of n integers and your task is to calculate
I have GPT. What is the problem, right?
the sum of each window of k elements from left to right. And in this problem, the input data is quite large and it is created using a generator. So in the input, the first line contains two integers n and k, that is the number of elements and the size of the window. And the next line contains four integers x, a, b, and c, and this will be used as the input generator parameters, right? And how we will generate the input. So the function is written here. So the first element of the array will be equal to this given x, right? And the remaining values will be generated using this formula, that is a into the previous element plus this b value mod the c value given. Right. So in this way, our input array will be generated. So that means our array is not given directly, and we have to generate it using the generator function. And what we have to do in the output is we have to print the XOR of all the window sums, right? So for each window of k size, right? So our k is also given. So for each window of k size, we have to compute the sum of that window, and we have to XOR the sum of each individual windows with each other, right? And as you can see that the value of k and n can go up till quite high, that is 10 to the power 7, and the value of xab can also go very high up till 10 to the power 9, and similarly for c, right? So here is an input given, and for this input, the expected output is 12. So let us move forward and try to understand this problem with an even bigger example, right? So that it would be easier for you to understand it very clearly. So let us move forward. So let us consider this example here. And in this example that I have considered by myself, let's say using the input generator function that is given in the problem, you are able to generate, let's say, using the input generator function that is given in the problem, you're able to generate this array that is starting from the first index and going till the 10th index, right? So since I always want to use one-based indexing in case of these types of problems, so that's why I considered this 0th index element, that is the 0 by myself. So it is not actually present in the given array. So the only elements that you're given with is from 1 to 10, right? So this is the original given array you will be given with, let's say, and the size of the window that you want to compute the answer for is k equal to 3, right? So the value of n is equal to 10, that is from 2 to 5, and the size for each window should be 3, right? So this is the input, and what is our task? Our task is to calculate the sum for each window of size 3, that is, for window has a size of 3, then I want to compute the sum for the next window, that is starting from 2 and going till 4, because this will be again of the size 3, and similarly we will move one step starting from our window 3 will be given that this I all generate this. Let us clear for you to understand it very well. And in this example, problem, you are able to generate this array that is starting from the first index and going till the 10th index, right? I have complement with, so the value of n is equal to 10. Input site is from 1 to start forward, right? So this particular
Hi, excuse me.
we take the prefix sum of the given array that I have considered. So the prefix sum will come out something like this. So this will be the prefix array of that array that I have considered, right? So now if someone asks you to calculate the sum of all the elements in this range, let's say sum of all the elements, let's say from 3 to 8, right? From 3 to 8 you want the summation. So what is the summation from 3 to 8? It should be 3 plus 1 plus 7 plus 1 plus 9 plus 0. So it should be equal to 3 plus 1 4, 4 plus 7 11, 11 plus, we want 20. Ask you simple is we first take the
These are all CSCS problems. Yeah. Oh, finally. Okay. Why though? previous. Of previous is greater than previous of previous. And previous is greater than this. If previous is smaller than previous. Wait, I can't count this correctly. But you count one extra waviness event somewhere else. So feeding test case is this. Oof. Hmm. Uh, What is the problem number? 3759.